Welcome to the Snoozy Scientist, a calm corner of the universe where curiosity and science drift together to put you to a calm sleep. Tonight, we're traveling into the silence of vanished oceans. For millions of years, vast inland oceans have risen and fallen, carving landscapes, nurturing ecosystems, and shaping the destinies of entire continents. These seas seemed eternal, stretching for thousands of miles, alive with storms, tides, and countless creatures. And yet, one by one, they disappeared. But what happens when life's most vital resource abandons the creatures who depend on it? What did these vanished seas leave behind? What strange worlds emerged from their absence? And why do oceans that seemed eternal disappear without return? Tonight, we'll step softly into these forgotten waters to uncover the seas that dried away, the hell they left behind, and the quiet warnings they still whisper to us today. But before we begin, I would love to know where in the world you're listening from and what the time is there. I always imagine this calm little community scattered like starlight across the globe, sharing the same story beneath different skies. If you enjoy these gentle journeys into Earth's past, please do consider leaving a like and subscribing to the channel. A warm thank you as well to those who are already subscribed. You help this quiet corner of science grow. Now take a slow, deep breath. Let your shoulders relax. Close your eyes if you'd like. And let's step gently into the story of when water betrayed life. There was a time when North America was not a single unbroken landmass. From the Gulf of Mexico all the way to the Arctic, a vast sea stretched across its middle, dividing the continent into two separate halves. This was the western interior Seaway, a body of water so immense that it covered nearly one-third of the land that we now know as the United States and Canada. Imagine standing in the center of the continent today, surrounded by plains and mountains, and then replacing that entire expanse with a warm, shallow ocean. It was a world of waves where land now lies, a place where seashells still rest buried in the stones of Nebraska, Kansas, and Wyoming. The western interior Seaway was not like the deep open oceans of today. It was shallow, often only a few hundred feet deep in places, yet it stretched for thousands of miles in length. Sunlight could reach the seafloor in many areas, creating rich habitats filled with life. The climate along its shores was humid and warm, and forests of conifers and ferns grew in the coastal regions. In the water itself, countless forms of marine life thrived, turning the seaway into one of the most productive environments on Earth. The most famous inhabitants were the mosasaurs, marine reptiles that could grow longer than a school bus. They were powerful predators with double-hinged jaws that allowed them to swallow prey almost whole. Fossils show they were sleek and muscular, built for speed, with tails that powered them through the water like giant lizards adapted to an oceanic life. Their eyes were large, perfect for tracking prey in the shifting light of the sea, and their teeth were sharp and curved, designed to grip slippery fish and ammonites. When a mosasaur lunged through the water, everything smaller scattered, but the mosasaurs did not rule alone. Sharks also prowled the seaway, including ancient relatives of the great white, with teeth that reveal their long history as apex hunters. Ammonites, with their spiral shells, drifted through the waters in enormous numbers. Some species were small, no larger than a coin, while others grew to several feet in diameter, their ribbed shells providing protection against many, but not all of the predators. In addition, there were giant turtles, fish with armor-like scales, and marine birds that skimmed the surface, looking for schools of prey. Above the waves, pterosaurs soared on wings that stretched wider than the length of a person. They dove into the shallows for fish, their long beaks snapping up unlucky swimmers. The skies were alive with these reptilian flyers, while the waters teemed with reptiles, fish, and invertebrates of astonishing variety. To stand on the shore of this seaway would have been to witness a scene both familiar and utterly alien, where the forms of life resembled creatures we know, yet with shapes and sizes that no longer exist today. The seaway also left behind a record of extraordinary abundance. As organisms died, their remains settled onto the seafloor, forming thick layers of organic material. Over millions of years, this built up into sediment that would later transform into rich deposits of chalk and limestone. Even today, these rocks tell the story of the creatures that once filled the western interior seaway, from microscopic plankton to enormous marine reptiles. Each layer of stone holds a frozen moment of life from a world that no longer exists. The presence of this sea reshaped not only ecosystems, but also the geography of the continent. It split North America into two long, narrow land masses. To the west lay Laramidia, a strip of land that stretched from Alaska down to Mexico, while to the east lay Appalachia, a landmass bordered by the Atlantic Ocean. Dinosaurs roamed both sides, but they were isolated from one another by the seaway. This isolation gave rise to unique species in each region. The dinosaurs of Laramidia, for example, included the ancestors of Triceratops and Tyrannosaurus, while Appalachia developed its own distinct fauna, preserved in rarer fossil finds. Over time, the seaway expanded and contracted with changes in sea level. At its greatest extent, it was more than 600 miles wide and thousands of miles long, transforming the heart of the continent into an inland ocean. Yet eventually, the forces that created it began to shift. As tectonic plates moved, mountain ranges like the Rockies began to rise in the west. The sea slowly lost its depth, its waters retreating as new land pushed upward. Rivers carried sediments into its basin, gradually filling it. What had once been a thriving ocean became shallows, then wetlands, and finally plains. The disappearance of the seaway forever reshaped North America. Its retreat left behind some of the most fertile soils in the world, created by sediments that had accumulated over millions of years. These same soils would one day support the great grasslands of the central United States, turning ancient seafloors into the breadbasket of a continent. Fossilized remains embedded in these rocks provide a lasting record of a vanished ocean and its creatures. Today, the Badlands and other rocky landscapes reveal skeletons of marine reptiles, shells of ammonites, and the impressions of plants that once grew on its shores. Where waves once rolled and mosasaurs hunted, there is now open sky and dry earth. The western interior seaway is gone, but its imprint remains etched into the very shape of the land. The fossils uncovered there are not only relics of a prehistoric sea, but reminders that even oceans can come and go, reshaping continents in their wake. When the western interior seaway finally gave way to the slow hand of time, it left behind a landscape that would one day tell its story in stone. Where waves once stretched from horizon to horizon, there are now plains, rolling hills, and badlands carved by wind and rain. The heart of North America, once divided by water, became a patchwork of exposed rock and sediment. Those layers, stacked one upon another, preserved not just the memory of the sea, but the remains of the creatures that lived and died within it. In South Dakota, North Dakota, Montana, and into Canada, the Badlands rise as a labyrinth of buttes and gullies, their striped cliffs revealing millions of years of history. The colors of the rocks shift with each band of sediment, some gray, some rust red, others pale yellow, each marking a different moment in time. To a geologist, the cliffs are pages of a book, with each layer recording a chapter of the seaway's story. What was once ocean floor now stands exposed to the open air, its secrets slowly unveiled by erosion. Beneath these surfaces lie the fossil graveyards of the Seaway. Marine reptiles, once rulers of the water, are found entombed in limestone and shale. The skeletons of mosasaurs, with their long jaws and powerful tails, have been uncovered in astonishing detail. Some fossils reveal entire skeletons preserved together, as if the animal sank into the mud of the seafloor and never rose again. Others show tooth marks on bone, hinting at ancient struggles between predator and prey. These remains speak of a world where danger lurked in every shadow, where survival was a constant contest between hunter and hunted. Not only mosasaurs, but also plesiosaurs with their long necks and paddle-like limbs have been uncovered, their graceful forms frozen in stone. The broad bodies of giant turtles appear in the fossil record as well, silent reminders of the strange and varied creatures that once drifted with the tides. Ammonites, with their coiled shells, litter the rocks in numbers so great that they can still be found by those walking along exposed outcrops. Some shells are small and fragile, others immense and ribbed like spirals of stone, each marking a life once lived in the shallow waters of the inland ocean. Fish, too, remain preserved in abundance. Some of these fish had armor-plated scales, others were swift predators with sharp teeth. Entire schools may have been caught in the same fate, swept together by currents, buried by sudden storms, and sealed beneath sediment. In some layers, delicate details of fins and scales remain visible, their patterns etched into rock as if time itself paused to capture them. These fossils remind us that the Seaway was more than just a home for giants. It was also alive with smaller creatures whose stories are equally vital to the record of life. The graveyards also reveal sudden changes in the sea itself. Geologists have found layers where the fossils are dense, piled together as though catastrophe struck without warning. These mass accumulations may have been caused by storms so fierce they churned the shallow waters and buried creatures in waves of sediment. They may also mark times of low oxygen when the sea itself turned hostile and life suffocated in its depths. Each layer is a clue to the rhythms of a vanished sea, a record of calm periods interrupted by disaster. The Great Plains, now a region of grass and open sky, also hold traces of this marine world. Beneath the soil, layers of chalk and shale stretch for hundreds of miles, each filled with the remains of seaway life. Farmers plowing fields in Kansas and Nebraska have sometimes unearthed the bones of ancient reptiles or the shells of ammonites, silent reminders that their land was once seabed. The chalk deposits, white and powdery, are composed of countless microscopic skeletons of plankton that thrived in the sunlit waters. When viewed under a microscope, these tiny fossils reveal exquisite detail, proving that even the smallest creatures played a role in shaping the record of the sea. One of the most haunting aspects of these fossil graveyards is the way they capture motion and life at the moment of death. Some mosasaur skeletons are found with smaller prey still inside their stomach cavities, showing us their final meal. Ammonites with bite marks record the struggles they endured before sinking to the bottom. Even fish caught mid-swim have been preserved in layers of fine sediment, as if frozen in time by the retreating waters. It is through these details that the Seaway feels less like a distant abstraction and more like a living world that is simply shifted out of reach. The retreat of the western interior Seaway did not erase its story. Instead, it left behind a stage set with evidence waiting to be uncovered. The Badlands, the Great Plains, and countless quarries across North America stand today as immense museums of stone where the past is revealed with every excavation. Each fossil uncovered from these beds brings new insight into the richness of life that once filled an inland sea. They tell of abundance and extinction, of calm and catastrophe, of a world both alien and familiar that has vanished but not been forgotten. Long after the western interior seaway had vanished from the heart of North America, another immense inland sea stretched across a different part of the world. This was the Paratethys, a body of water so vast that it dwarfed the Mediterranean Sea of today. At its height, it extended from the rolling plains of Central Europe all the way into Central Asia. Its surface glittered under ancient skies, covering an area larger than all of modern Europe combined. Imagine standing at its shore and knowing that to cross from one side to the other would take longer than crossing the Mediterranean itself. The Paratethys was born during the slow collision of continents. When Africa pressed northward into Eurasia, new mountain ranges rose, cutting this sea off from the great Tethys Ocean. What had once been part of a broad and connected marine realm became isolated behind high ridges and shifting land. Its waters no longer flowed freely into the global ocean. They became trapped in a basin surrounded by land, a world unto itself. At first, this sea was full of life, connected enough to host many of the same creatures found in the open waters beyond the mountains. But as the isolation deepened, its fate began to turn. Without steady exchange with the wider ocean, the Paratethys became vulnerable to changes in climate and geography. Rivers brought fresh water into it, yet evaporation constantly worked against them. During warm periods, vast portions of the sea shrank. Shorelines retreated by hundreds of miles, leaving behind muddy flats and salt marshes where waves had once rolled. In some epochs, the Paratethys nearly disappeared altogether, breaking into a series of smaller, shallow lakes and briny pools. Each time the waters withdrew, life within them was pressed closer to the edge. The creatures of the Paratethys adapted in ways both remarkable and strange. Dolphins that once swam freely in the open ocean found themselves cut off inside these shrinking waters. Fossil evidence reveals that some evolved to cope with the brackish, low salinity environment, their bodies adjusting to conditions unlike those of their ancestors. These dolphins became smaller and more specialized, unique to this isolated sea, unable to survive outside it. Fish, too, followed this path. Some species shrank in size, while others developed unusual features suited to the changing chemistry of the water. Trapped in a basin that often teetered between fresh and salty, they had nowhere to escape. The sea was not static. At times it swelled again, fed by river systems and fleeting reconnections with other water bodies. When that happened, new migrations occurred. But each reconnection brought instability as well, because species adapted to a nearly freshwater world suddenly faced the return of saltier currents. Entire populations rose and fell in cycles dictated by forces they could not control: rainfall, evaporation, tectonic uplift, and subsiding land. To the animals that lived there, the Paratethys must have felt like a world that could never be trusted, a sea that could vanish beneath them without warning. Geologists piecing together its story find evidence of its restless nature written in stone. Thick layers of evaporites composed of salts and minerals reveal times when the sea retreated so far that it became little more than a collection of shallow, briny basins. At other levels, rich deposits of organic matter show when life flourished in its waters. Fossil beds uncover entire schools of fish, clustered together as if trapped by a sudden change in salinity or a rapid drop in oxygen. The Paratethys, like a living creature, pulsed through cycles of expansion and contraction, each one reshaping the life within it. The human eye can still see its imprint today. The Black Sea, the Caspian Sea, and the Aral Sea are all remnants of this once mighty giant. These modern seas are like broken shards of the Paratethys, scattered across the map of Eurasia. The Caspian remains the largest inland body of water on Earth, and its existence is a lingering echo of that vanished supersea. The Aral, now mostly gone, was once part of the same story. Even the Black Sea, which connects to the Mediterranean through the narrow Bosporus, retains chemical traces of its Paratethys heritage. When one stands on the shores of these waters, one is standing on the edges of a sea that was once unimaginably larger. The story of the Paratethys is also the story of how isolation shapes life. Unlike the western interior Seaway, which was full of creatures known from open oceans, the Paratethys produced its own strange cast. Its endemic dolphins, its unusual fish, and its alternating chemistry created a world apart, as if Earth had set aside this basin to conduct experiments in evolution. When the waters finally pulled back for the last time, many of those creatures vanished forever, unable to find refuge elsewhere. Their fossils, scattered across the basins of Eastern Europe and Central Asia, tell of lives lived in a sea that was always slipping away. Standing in the present, it is difficult to picture just how immense the Paratethys once was. The rolling grasslands and deserts of today conceal its memory, yet the sediments below keep its records safe. With every core drilled into the earth, with every fossil uncovered, scientists bring more detail to a world that has been lost to the eye but not to time. The vanished giant of Europe and Asia may be gone, but it continues to reveal how seas live and die, and how their endings reshape the landscapes and the life that come after. When the Paratethys began to fade, it did not disappear with quiet dignity. Its retreat was drawn out, a slow unraveling that left deep marks across Eurasia. The sea's waters pulled back, basin by basin, until only scattered lakes and briny shallows remained. What it left behind was more than absence. It left scars of stone, chemistry, and silence that still shape the land today. As the shallow waters dried beneath relentless summers, their minerals became more concentrated. Every drop that evaporated left behind a trace of sodium and calcium, of gypsum and chloride. Over centuries, then millennia, these invisible traces thickened into tangible sheets of salt. Layer upon layer, hardened into deposits so vast they now measure hundreds to thousands of meters deep. Beneath the plains of Eastern Europe and Central Asia, these salt beds still lie buried, a crystallized memory of a sea that once stretched from horizon to horizon. In time, tectonic pressures folded and pushed these layers upward into great domes of salt. Some rose high enough to warp the land above them, creating rolling ridges and subtle hills across the otherwise flat basins. Today, these salt domes are not just curiosities for geologists. They are mined and quarried, their minerals feeding industries, roads, and economies. Entire cities depend on the resource left behind by a vanished ocean. When a miner lifts a block of crystalline salt from deep underground, they are holding a fragment of the Paratethys itself, a piece of vanished water made solid. But salt was only one part of the story. As the sea became more restricted by rising mountain chains, circulation slowed, vast stretches of water were cut off from renewal and began to stagnate. Without oxygen moving through the water, entire zones suffocated. Fish and mollusks that had once thrived in abundance could no longer survive. Their bodies settled into the darkening mud, and over time, those muds transformed into shale, rich with organic matter. These rocks preserve a haunting record, not of a thriving ocean, but of a sea turning against its inhabitants. The brines that formed in isolated basins became especially hostile. Evaporation did not just concentrate common salts, it intensified everything, including trace metals and chemicals leached from surrounding rocks. In some pockets, the water grew so caustic that almost nothing could endure it. Fossil records show sudden disappearances of species once common to the Paratethys, as if whole populations had been erased by invisible poisons. Where dolphins once chased fish through inland waters, there came only silence, as chemistry transformed life's cradle into a trap. The retreating waters also exposed vast stretches of fine silt and clay. Once hardened under the sun, these plains cracked and lifted with the wind. Storms swept across Eurasia, carrying the lightest particles far from their origin. Dust from the bed of the Paratethys settled across valleys, plains, and even mountain slopes. Traces of these journeys can still be found in soils that blanket regions thousands of kilometers away. Farmers tilling the land of Eastern Europe and Western Asia are unknowingly working fields touched by the dust of a vanished sea. Unlike later global scale dust stories, this was a distinctly Eurasian ghost, carried on the breath of winds that once swept unhindered across the empty basin. The physical fingerprints of the Paratethys are visible even now. The Caspian Depression, the plains of Ukraine, and parts of Kazakhstan still bear the shimmer of salt left behind. Shallow pools bubble up through hidden salt layers, their waters dense and briny, echoes of the ancient chemistry that once filled an entire inland ocean. These are the modern shadows of the Paratethys, places where land and water seem unsettled, unsure which they belong to. For humans, the inheritance of this vanished sea has been paradoxical. On one hand, its salt domes are treasures. They have supported economies for centuries, supplying essential minerals, preserving food, and paving roads. They have also created structural traps for oil and gas, meaning the energy that fuels cities today was shaped by a vanished sea long ago. On the other hand, the exposed basins left behind have sometimes turned hostile. Dust lifted from ancient seabeds can erode soils and weaken agriculture, affecting communities in ways subtle yet persistent. Drilling cores taken from beneath these regions reveal the story in sharp detail. Each layer of rock salt, shale, and fossil debris reads like a page in a diary. Times of plenty are marked by shells and corals, while times of decline appear as black mud suffused with organic matter. Salt itself is a signature of retreat, the mineral handwriting of a sea taking its last breaths. Scientists reading these records see not a smooth decline, but a series of pulses. The Paratethys shrank and swelled, suffered partial recoveries, then collapsed again, each episode etching a fresh mark into stone. It is tempting to imagine the end of a sea as a simple emptiness, but the death of the Paratethys was anything but simple. It was a transformation, sometimes violent, sometimes subtle, that unfolded over millions of years. The waters thickened into brine, life ebbed away, minerals crystallized, and winds lifted the remnants into the air. The land was reshaped, its soils altered, and its underground wealth sealed for future hands to uncover. The Paratethys may be gone, but its memory is inscribed in the hills, the plains, and even the economies of Eurasia. Its salt glitters in mines, its dust lingers in soils, and its chemistry still seeps through springs and marshes. A vanished ocean continues to speak, not with waves and tides, but with the crystals it left behind, with the winds that carry its breath, and with the enduring silence of a sea that once was. In the heart of Egypt's western desert lies a place where time feels twisted, where sand and silence conceal a story so strange it defies belief. This is Wadi al-Hitan, the Valley of the Whales. At first glance, it appears as nothing more than a barren desert, its golden dunes rolling into the horizon beneath a searing sun, but scattered across the sand are bones, vast and unmistakable. The skeletons of whales lie exposed, their curved spines arcing out of the earth, their rib cages frozen mid-breath, as if the sea that once carried them vanished in an instant and left them stranded forever. These fossils tell of a vanished ocean that once stretched across this now desolate land. Millions of years ago, during the Eocene epoch, the area was not desert at all but a shallow sea. Its waters were warm and filled with life, home to early whales that were only just beginning to claim the ocean as their permanent home. The creatures preserved here are not quite like the whales we know today. They were transitional forms, bridging the gap between land-dwelling ancestors and the fully aquatic giants that glide through modern oceans. One of the most striking fossils found in Wadi al-Hitan belongs to Basilosaurus. Despite its name, which suggests a reptile, Basilosaurus was a whale. It stretched more than 50 feet in length, with a serpentine body that undulated through the water. Unlike today's whales, Basilosaurus still carried small hind limbs, tiny and useless for walking, but visible reminders of its land-based ancestry. Its teeth were sharp and conical, built for tearing flesh. These whales were hunters, prowling the Eocene seas for fish and smaller marine creatures. To see their skeletons lying in the desert today is to witness an extraordinary contradiction. Creatures that belong to the sea, preserved in stone where no water remains. Another fossil found in this valley is Dorodon, a smaller whale that likely swam alongside Basilosaurus. Dorodon was closer to modern whales in shape, with a streamlined body built for efficient swimming. Its fossils reveal details of how early whales adapted to a fully aquatic lifestyle. The delicate bones of the inner ear, preserved in remarkable detail, show structures that allowed these animals to hear underwater. Even in death, there remains whisper of a world in transition, when mammals were still learning how to master the ocean. The preservation at Wadi al-Hitan is so complete that entire skeletons remain intact, their bones still aligned as if the flesh had melted away while the bodies lay gently on the seabed. The conditions were perfect for fossilization. As the whales died and sank, they were quickly covered by layers of sediment in the shallow sea. Over millions of years, the waters retreated. Tectonic forces lifted the land, and erosion revealed the bones once more. What was once the bottom of an ocean became desert floor, and the silent tomb of these whales opened to the air. Walking among the fossils today feels otherworldly. The desert wind brushes over sand that once formed seabeds, and the bones stretch out in directions that echo the currents of an ancient ocean. Scientists carefully study these remains, but even for them, the experience is haunting. The valley speaks of both life and loss. It is proof that even the largest creatures can be humbled by the restless nature of Earth. Whales that once dominated their world now lie silent, their skeletons weathered by a sky they never knew in life. What makes Wadi al-Hitan especially powerful is that it does not only show us the grandeur of vanished seas, but it also captures a turning point in evolution. These fossils reveal the very moment when mammals fully embraced the sea, leaving land behind. They are missing pages of life's story, written not in ink, but in bone and stone. Without them, our understanding of whale evolution would be incomplete. Here, in this desert, the journey of whales from land to sea is preserved with stunning clarity, as if the earth itself wanted to remember. The site is now a UNESCO World Heritage location, protected not just for its scientific value, but for its beauty and strangeness. The fossils lie open to the sky, as if staged for memory. Visitors describe it as a place where time collapses, where the sea and the desert overlap in ways the mind struggles to reconcile. The silence is broken only by the wind, which seems to carry the echo of waves that no longer exist. In this valley, the bones of giants remind us that water, the very element that gives life, can also betray it. Seas shift and vanish, leaving behind creatures that cannot follow. The whales of Wadi al-Hitan once swam freely through warm shallows, yet today they rest in scorching sand. Their story is not one of failure, but of change. For while their kind perished here, whales themselves endured, evolving into the magnificent beings that still grace our oceans. And as the desert holds these bones, the land whispers a quiet warning. Even giants can be stranded when the waters turn away. The Mediterranean Sea, as we know it today, is a place of timeless beauty, waves lapping against rocky coasts, ships tracing ancient trade routes, and waters alive with dolphins and fish. But just under 6 million years ago, this sea nearly ceased to exist. What happened is known as the Messinian Salinity Crisis, one of the most extraordinary environmental shifts Earth has ever endured. The trigger was the slow but relentless movement of continents. The African plate pressed northward into Europe, raising the mountains that would one day form the Alps and Pyrenees, and pinching closed the narrow gateway at Gibraltar. This thin channel, which today allows the Atlantic to flow into the Mediterranean, was sealed. The sea was cut off from its source of renewal, left to survive on nothing but rivers, rainfall, and what little groundwater seeped in from the surrounding land. At first, the Mediterranean lingered, still filled with water, though already in decline. But as the sun blazed above and the climate warmed, evaporation took more than the rivers could supply. Drop by drop, year after year, the water level fell. Scientists believe that within a matter of thousands of years, much of the sea had either dried into isolated basins or shrunk to hypersaline lakes, clinging desperately to the lowest depressions. The change in landscape was staggering. Imagine standing at what is now the coast of Italy and looking out, not at a glittering horizon of blue, but at a vast expanse of white salt flats, broken by pools of brine that shimmered red and green under the fierce sun. The air would have been heavy with the sharp sting of salt, and the silence broken only by the dry crack of wind across the crusted plain. Rivers that once flowed gently into the sea were forced to carve deep gorges as the water level fell. The Nile, the Rhone, and countless smaller rivers plummeted into the deepening basins, cutting canyons that in some cases were deeper than the modern Grand Canyon. These gashes in the landscape remain buried beneath sediments today, a hidden reminder of rivers that once tumbled down cliffs to reach a dying sea. Life, too, was transformed. The Mediterranean that had once supported coral reefs, schools of fish, and great pods of whales became a place of death and scarcity. As the salinity rose, species vanished. Only a few creatures adapted to briny lagoons clung to survival in shrinking pockets of water. Fossils tell us that even hardy mollusks and crustaceans disappeared from vast stretches of the basin. The abundance of life that once fed ancient coastlines was erased, replaced by a silence that must have seemed eternal. The climate of the surrounding lands shifted as well, with the Mediterranean no longer acting as a vast reservoir of moisture. Rainfall patterns across southern Europe and northern Africa changed. Dust storms rose from the exposed seafloor, blowing grit and salt across the continents. Croplands that might have flourished along the coast turned barren, while ecosystems across Europe and Africa adapted to new, harsher rhythms. For humans, millions of years in the future, the Messinian Salinity Crisis would leave more than a scientific puzzle. It left scars that shaped the very geology of the Mediterranean basin, terraces carved by ancient shorelines, deep canyons now buried, and chemical signatures in sediments all speak of a time when this familiar sea nearly vanished. The crisis lasted for hundreds of thousands of years, with the basin oscillating between near desert and shallow, saline lakes. It was not a single event, but a prolonged struggle between evaporation and replenishment. The image is almost surreal. Mountains surrounding what appeared to be deserts, vast plains where whales and dolphins once swam, and rivers plunging into abysses so deep they defied imagination. The Mediterranean basin became an alien landscape on our own Earth, a reminder of how fragile the balance of water can be. And then, as suddenly as it began, it ended. Just over 5 million years ago, the narrow barrier at Gibraltar failed. Atlantic waters surged back in, cascading into the basin in what scientists call the Zanclean flood. The refill may have taken only a few years, perhaps even months, depending on the flow. Waterfalls many times greater than Niagara thundered into the basin, and the dry, salt-stained plains were drowned beneath rising tides. Life returned slowly, but the scars of desiccation remained, locked in stone. The Messinian Salinity Crisis shows that even the greatest seas are not eternal. They can vanish, collapse, and leave behind landscapes almost beyond imagining. For geologists and paleoclimatologists, it is one of Earth's clearest reminders that climate, tectonics, and life are interwoven in delicate and sometimes catastrophic ways. The Mediterranean was remade by this event, and though it survives today as a vibrant sea, its buried memory is one of drought, silence, and near death. Beneath the calm blue waters of the Mediterranean lies a secret landscape that few would imagine. Today's sea stretches across familiar coastlines, binding Europe, Africa, and Asia in a glittering embrace. But deep under its floor rests a hidden world of salt, a world created during the Great Drought that nearly erased the sea from existence. The Messinian Salinity Crisis did not only transform the surface, it left behind colossal structures beneath the seafloor mountains of salt, buried and preserved, waiting millions of years to be discovered. The story of these hidden salt ranges first came to light in the 20th century, when geologists drilled into the seafloor. They expected to find layers of mud, sand, and marine sediments, the ordinary pages of ocean history. Instead, their drills pulled up something strange, thick cores of crystalline salt compressed into stone. At first, it seemed impossible. How could so much salt lie beneath one of the deepest seas on Earth? But as data accumulated from multiple sites, the picture became undeniable. The Mediterranean's floor is underlain by deposits of salt so immense that in some places they reach more than a mile in thickness. Spread across the basin, they cover hundreds of thousands of square miles, making them some of the largest evaporite deposits on the planet. To picture their scale is to imagine entire mountain ranges, not of granite or basalt, but of salt, lying hidden under layers of sediment. They are the mineralized memory of the sea's near death, created when the basin dried and refilled again and again over hundreds of thousands of years. Salt does not lie quietly beneath the ground. It behaves in unusual ways, flowing slowly like putty under the enormous weight of overlying rock. Over millions of years, the Mediterranean's buried salt has shifted and deformed, pushing upward into domes and ridges. Seismic surveys reveal these strange shapes, great bulges that rise through the sediments, bending the rocks above them. In some regions, the salt has trapped oil and natural gas, making it a focus of exploration. In others, it has warped the seafloor itself, creating hidden ridges that echo the restless history of the basin. These buried salt layers tell scientists much about the extremes of Earth's past. Each band within them represents a cycle of drying and flooding as the Mediterranean basin alternated between shallow lakes and near-empty deserts. In times of partial refilling, thinner layers of salt formed. In periods of complete desiccation, vast slabs crystallized in place. Drilling has revealed this rhythmic pattern, stripes of geology that capture the rise and fall of water levels over hundreds of thousands of years. Each stripe is like a line of poetry, written not with words but with minerals, recording how close the sea came to vanishing. The conditions that produced such layers must have been extraordinary. Imagine the basin at its lowest points, the sun blazing down, shallow pools of hypersaline water shrinking into nothing. As they evaporated, the minerals dissolved in them sodium, magnesium, calcium fell out of solution and settled as crystals. Over time, as this process repeated, entire landscapes of salt accumulated, later buried beneath new sediments when the waters briefly returned. The Mediterranean floor became a canvas of alternating wetness and desolation, a geological diary that still lies hidden under today's sea. One of the most remarkable aspects of these salt mountains is how they connect directly to the dramatic end of the crisis. Around 5.3 million years ago, the barrier at Gibraltar failed. Water from the Atlantic surged into the basin in what is known as the Zanclean Flood. Some models suggest that within just a few years, perhaps even within a few months, the basin filled, drowning the salt flats under thousands of feet of new water. The reflooding buried the salt layers forever, sealing them beneath marine mud and sediments. The surface was reborn as a thriving sea, but below, the mineral scars remained. For geologists, these deposits are more than curiosities. They are archives. Within their crystals lie chemical fingerprints of the ancient Mediterranean's waters, their salinity, their temperature, their chemical composition, trapped bubbles of brine, sealed for millions of years, provide tiny windows into the chemistry of a vanished ocean. By analyzing them, scientists can reconstruct the conditions that reigned when the sea was drying, offering insights into climate, evaporation, and the fragile balance of Earth's hydrological cycle. The buried salt also continues to shape the Mediterranean today. Subtle movements of these deposits influence earthquakes and seafloor stability. In some regions, the salt domes serve as natural traps for hydrocarbons, guiding energy exploration in countries around the Mediterranean rim. In others, they create geological hazards, with the potential to destabilize slopes and trigger submarine landslides. What was once the silence of a vanished sea still exerts a quiet force on the living world above it. To think of the Mediterranean only as it appears today is to miss half its story. Its tranquil surface hides one of the most dramatic geological archives on Earth, preserved not in fossils or rocks, but in vast mountains of salt. These hidden ranges remind us that seas are fragile, that they can vanish almost completely, and that their depths leave legacies long after their waters return. The next time we look at the Mediterranean, the blue expanse stretching between continents, seemingly eternal, it is worth remembering that beneath its waves lies the memory of drought and desolation. Buried salt mountains tell of a sea that almost ceased to exist and of the cataclysm that refilled it. They are a monument hidden under water, a testimony in crystal, waiting patiently for us to read. Long before the Mediterranean, long before the Atlantic even reached its modern shape, there was a far older ocean, a body of water so vast it stretched across the very heart of the earth. It was called the Tethys Ocean, and for untold ages it lay like a shimmering ribbon at the planet's equator, connecting oceans east to west, north to south, binding the world's waters into one. To imagine the Tethys is to picture a tropical sea stretching thousands of miles, warmer and shallower than today's deep oceans. Along its margins, reefs flourished, built by corals and shelled creatures that thrived in the sunlit shallows. Strange reptiles glided above its surface, while ammonites and other coiled-shelled wanderers drifted in its depths. It was not simply a sea, but a crossroads, a living highway between continents, carrying species, climates, and currents from one side of the world to the other. The Tethys formed in the deep past during the slow breakup of the supercontinent Pangaea. As the great landmass cracked apart, a gap opened and water rushed in. Over millions of years, this gap widened into a sprawling equatorial sea. For a time, it linked the ancient Panthalassa Ocean, which surrounded Pangaea, with new waters forming in what would become the Atlantic and Indian Oceans. The Tethys became the warm, beating heart of the planet, shaping climates far beyond its shores. Its waters cradled whole dynasties of life. Ichthyosaurs and plesiosaurs hunted its depths, while fish of every size darted among reefs and shallows. The ancestors of modern whales once swam in its tropical reaches, though they would later move into other seas. It was in the Tethys that many of Earth's most recognizable marine fossils were first laid down, their bones settling gently into the seafloor mud where they would remain for millions of years. But oceans, like continents, are never eternal. Slowly, the Earth's plates shifted, driven by the restless heat beneath the crust. The African plate drifted northward, creeping ever closer to Eurasia. The Tethys began to narrow. At first, the change was almost imperceptible. Islands rose where once there had been open water. Seaways that had connected vast basins shrank into narrow straits. The once limitless horizon of the Tethys began to close in, little by little, as if the ocean were being squeezed between two immense hands. Eventually, the collision came. Africa pressed into Eurasia, and the seafloor of the Tethys was forced upward. The weight of continents rising against one another folded rocks into mountain chains that still tower today. The Himalayas, the highest mountains on Earth, were born out of this slow but unrelenting clash. Where waves had once rolled, snowy peaks now pierced the skies. Beneath those mountains, the remnants of the Tethys are still visible, locked into layers of limestone that hold the shells of long-vanished marine creatures. The death of the Tethys did more than create mountains. It reshaped entire climates. As the ocean disappeared, the vast belt of warm, wet air that once drifted across its surface broke apart. Rainfall patterns shifted. Regions that had once been green and fertile dried into deserts. The Middle East, now defined by arid sands and rocky plateaus, owes much of its climate to the vanishing of the Tethys. Where fish had once swum and coral reefs had thrived, dust now drifts on the wind, and silence lies heavy over the land. Even today, echoes of the Tethys remain all around us. Fossils of marine creatures are found high in the Himalayas, proving that these peaks, now the roof of the world, were once a seabed. In deserts across the Middle East, layers of limestone and salt mark the vanished waters. In the rocks of southern Europe and northern Africa, geologists read the slow retreat of an ocean that seemed too vast to fail. Its memory is written in stone, from the Alps to the Zagros Mountains. The Tethys Ocean is gone, but its children live on. The Mediterranean, the Black Sea, the Caspian, and the Aral are all remnants, smaller seas that trace their lineage back to this once boundless expanse. Each of them carries a fragment of its story, a reminder that the great ocean, which once united the globe, has not disappeared entirely, but has scattered into pieces. The story of the Tethys is not simply about an ocean that vanished. It is about how the earth reshapes itself over time, trading seas for mountains, reefs for deserts, life for silence, and then, eventually, silence for life again. The ocean that once fed ecosystems across the planet became the force that lifted the tallest mountains, altered climates, and forever changed the course of evolution. Beneath every stone in the Himalayas, within every fossil reef in the deserts of Arabia, there lies a quiet echo of waves that once lapped across a vanished equatorial sea. The Tethys may no longer exist, but its legacy is everywhere, shaping landscapes, shaping weather, shaping the very bones of the earth. Even though the Tethys Ocean has long vanished, its memory lingers across the landscapes of our modern world. Its legacy is written not in water, but in stone. The fossils of the creatures that once swam in its blue expanse are scattered today across mountains, deserts, and plains, silent witnesses to an ocean that once girdled the earth like a vast equatorial belt. One of the clearest voices from that ancient sea comes from the ammonites. These coiled mollusks, cousins of modern squid and octopus, thrived in the Tethys. Their shells, spiraled with mathematical precision, drifted into soft sediments when they died, creating fossil layers that stretch for miles. Some were no larger than a thumb, delicate as seashells you might pick up on a beach. Others grew to the size of cartwheels, heavy, ridged coils that once floated in open water. Today, their fossils are often found in mountain ranges such as the Alps, lifted high above the clouds by tectonic forces that closed the Tethys itself. To hold one is to hold the pattern of a vanished sea, frozen in stone. Coral reefs also flourished in the shallow shelves of the Tethys. They built dazzling ecosystems, swarming with fish, crustaceans, and other life that depended on their intricate branches. As the ocean retreated, these reefs solidified into limestone, now towering as cliffs or lying buried beneath deserts. In places like the Himalayas, you can find fossil corals at altitudes higher than most birds can fly. Their presence there is almost surreal, as though a tropical reef had been lifted into the sky. These fossil corals remind us that the mighty mountains of Asia once lay beneath warm equatorial waters. The Tethys also left behind marine reptiles such as ichthyosaurs and plesiosaurs. Ichthyosaurs, streamlined like dolphins, cut through its waters in pursuit of fish and squid. Their large eyes, among the biggest ever evolved, help them hunt in dimly lit depths. Plesiosaurs, with long necks and flippered bodies, moved gracefully across the shallows. Today their bones rest far inland, sometimes in dry, wind-swept terrain, reminders that where sand now drifts, predators once swam. Each skeleton is a testimony to the fluid nature of Earth itself, where oceans can rise into mountains and waves can harden into stone. Perhaps the most haunting fossils tied to the Tethys are those of whales. In deserts that were once its shorelines, paleontologists uncover skeletons of early whales that still carried small, useless hind limbs, vestiges of a time when their ancestors walked on land. These fossils mark the great transition from land mammals back into the sea. Egypt's Wadi al-Hitan, the Valley of the Whales, holds famous examples, but it is far from alone. In Pakistan's Kurthar and Sulaiman ranges, entire skeletons of these proto-whales lie preserved in rocks that were once part of the Tethys seabed. These finds are particularly important because they capture a moment of transformation in the history of life. The whales that swam here were neither fully terrestrial nor fully aquatic, but creatures in between, reshaping themselves to thrive in the embrace of the ocean. The reach of the Tethys extended across regions that seem unconnected today. In the deserts of North Africa, whale bones rest in sand, while ammonite shells lie entombed in the peaks of southern Europe. The Middle East holds stretches of limestone that were once vibrant reefs, and South Asia preserves the story of marine mammals adapting to their new watery homes. Together, these scattered traces weave a single narrative that a vast ocean once tied these lands together before it disappeared into history. Scientists studying these fossils find more than shapes of bone or shell. Within them lie chemical fingerprints of the vanished sea. The isotopes in coral limestone reveal the temperature of the water where the reefs once grew. The chemistry of whale teeth records the salinity of the seawater they drank and the diets they pursued. Even microscopic details hold clues. Some shells preserve growth rings that trace seasonal shifts in the Tethys, much like tree rings tell of years gone by. In this way, the fossils are not just relics, but archives, keeping alive a record of climate, chemistry, and life in a world that no longer exists. The Tethys also shaped the course of evolution. As the ocean narrowed and fractured into smaller basins, species became trapped. Some adapted, diverging into new forms that never spread elsewhere. Others perished when their habitats vanished. These evolutionary bottlenecks influence the diversity of marine life we see today. The ancestors of modern whales and dolphins, for example, passed through this ocean, carrying its legacy forward into the Atlantic and Indian Oceans. Even after the sea itself vanished, its influence rippled through time, woven into the biology of the creatures that inherited its waters. To stand in a desert where whale bones rest, or to climb a mountain where corals are etched into stone, is to touch the ghost of the Tethys. It is to realize that our solid earth is far from fixed, and that oceans can rise, shift, and disappear entirely. The survivors of the Tethys are more than fossils. They are storytellers, whispering across millions of years that no sea, no matter how vast, is eternal. When we think of the Sahara today, we think of endless waves of sand stretching beyond the horizon, dunes rising like golden mountains, and air so dry that a single drop of water seems precious. It is a place of extremes, where the sun beats without mercy, and the silence is so complete it can feel eternal. Yet hidden beneath this arid surface lies a very different story, one written in fossils, sediments, and the quiet memory of vanished waters. The Sahara has not always been the desert we know. Many times in the past, this vast expanse was green, alive with rivers, wetlands, and even seas. During wetter ages, seasonal rains fell across the region, feeding great lakes that covered hundreds of miles. The land bloomed with grasses, trees, and savannas where herds of animals grazed. Today, when scientists dig beneath the dunes, they find evidence of these forgotten worlds locked in stone. Fossil fish appear in places where no water has flowed for thousands of years. Their scales, preserved in desert sediments, tell us that once entire schools darted through lakes that shimmered under the African sun. Crocodile remains lie buried in the sand, their bones a reminder that these apex hunters once basked on riverbanks, now dry and desolate. Perhaps most haunting are the fossils of hippos, creatures that require abundant water to survive. To find their bones deep in the Sahara is to realize just how transformed this landscape has become. The presence of seas is recorded too. Geological evidence shows that ancient marine waters once reached far into North Africa. Layers of limestone, rich with the shells of tiny sea creatures, stretch across the desert and rise into cliffs that today overlook empty plains. These rocks were once seafloors, laid down grain by grain when the Sahara was submerged beneath warm, shallow oceans millions of years ago. To climb one of these cliffs is to walk upon what was once a shoreline, now stranded hundreds of miles from any modern sea. The greening and drying of the Sahara is tied to the rhythms of the earth itself. Our planet does not orbit the sun in a perfect, unchanging path. Over long cycles, the tilt of Earth's axis and the shape of its orbit shift slightly. These changes, called orbital cycles, alter how much sunlight reaches different parts of the world at different times. In North Africa, they can mean the difference between desert and grassland. When conditions align, monsoon rains push northward, transforming the Sahara into a land of rivers and lakes. This happened as recently as 10,000 years ago, during what is called the African humid period. Archaeologists have discovered rock art from that time, painted on cave walls and stone outcrops, showing scenes of cattle herding, hunting, and swimming. people lived in places that today are uninhabitable, supported by water and wildlife that seem impossible in the present landscape. But when the cycles shift again, the rains retreat, lakes dry up, rivers vanish, grasslands wither into sand. Slowly, the desert reclaims the land, spreading its dunes across valleys where hippos once wallowed. The transformation can happen surprisingly quickly in geological terms, sometimes within only a few centuries. Entire ecosystems collapse, leaving behind only traces in fossils, sediments, and stone carvings. For scientists, the Sahara is like a vast archive of these oscillations. Beneath the dunes lie layers that alternate between wet and dry, lush and barren, each one a chapter in a repeating story. These layers reveal that the Sahara has flipped between green and desert many times over the past few million years. It is not a fixed landscape, but one that breathes in rhythm with the slow heartbeat of Earth's orbit. The discovery of these lost seas and lakes reshapes how we imagine the desert. The Sahara we see today is just one version of its many faces. Beneath the silence of the sand lies the memory of rushing rivers, the cries of birds across wetlands, and the heavy footsteps of elephants moving through tall grasses. Beneath the dunes are the bones of fish, crocodiles, and hippos that once swam where now only mirages shimmer. It is a reminder that even the harshest deserts can remember water, and that what feels eternal in our eyes is often only temporary in the vast scale of geological time. The Sahara is not only a desert of sand, but also a desert of memory, holding within it the ghosts of seas and lakes that once defined its land. In the heart of Africa, where the desert edges meet the Sahel, there once lay a lake so vast it could rival inland seas of legend. This was Lake Chad, a freshwater giant that at its height spread across an area larger than modern Germany, stretching for hundreds of miles in every direction. It was not simply a lake but an inland ocean, a mirror of blue glimmering under the African sun, and for a time it was one of the largest bodies of water on the planet. To stand at its ancient shoreline would have been to witness horizons dominated by water. Waves lapped against grassy banks where crocodiles basked and herds of antelope came to drink. The air was filled with the calls of birds that thrived in its wetlands, and the fishing grounds were rich with species that swam freely through its open waters. Lake Chad was a hub of life, nourishing both ecosystems and early human communities who settled along its shores. But like many of the seas before it, this giant was not eternal. Over the past 20,000 years, Lake Chad began to shrink. At the peak of the last ice age, it reached its greatest extent, covering more than 130,000 square miles, an area greater than the Caspian Sea. But as the world warmed, rainfall patterns shifted. The great humid periods that once fed its waters grew shorter and less reliable. Rivers that once poured into it slowed, their flow interrupted by the advance of aridity across the Sahara. What remains today is Lake Chad, a small remnant clinging to survival on the borders of Chad, Niger, Nigeria, and Cameroon. Once an inland ocean, it has been reduced to a patchwork of shallow lagoons, marshes, and seasonal ponds. At times in recent decades, its size has dwindled to less than 1/20th of its former glory. Satellite images reveal its retreat, showing dark scars of old shorelines curving across the landscape, like ghosts of waves that no longer rise. For scientists, this dramatic transformation is more than a story of drying water. It is a key to understanding the delicate balance of climate and life in Africa. Sediments taken from beneath the old lakebed are rich with pollen, shells, and chemical markers. They reveal how the lake swelled and retreated in rhythm with shifts in Earth's orbit, monsoons, and global temperatures. These records show that Megachad expanded and contracted many times, each cycle shaping the land, its creatures, and the people who lived nearby. The drying of Lake Megachad also left behind striking geological features. As the water retreated, it carved channels and deltas that now lie stranded in the desert. Fossilized shorelines still ripple across the ground, visible from space as faint arcs and ridges. Beneath the sand, thick layers of freshwater sediments remain, storing traces of the creatures that swam in its waters. Fish fossils, freshwater mollusks, and even the bones of hippos tell us of a time when this place was green, lush, and alive. For humans, the shrinking of the lake has been a challenge and a warning. For thousands of years, people relied on it for fish, for fertile soils along its margins, and for a steady supply of water. Ancient communities left tools and pottery along its banks, evidence of settlements that prospered when the waters were high. Today, millions of people still depend on what is left of Lake Chad, though its unpredictable retreat has created hardship. Fishermen, farmers, and herders all feel the pull of a shrinking resource, just as animals once did when past drying cycles reshaped the land. In many ways, Lake Chad is a living echo of the vanished seas that came before it. Like the western interior Seaway, like the Paratethys, it shows how water can transform continents and how its absence can just as swiftly undo them. Though smaller now, its waters still feed wetlands where herons stalk fish and reeds sway in the wind. Each year, rains bring some renewal, but the long-term trend remains one of decline. The story of Megachad is still unfolding, and scientists watch carefully, knowing that it reflects patterns of change far larger than this single lake. Perhaps what makes Lake Megachad so evocative is its dual nature. It is both ancient and modern, both a fossil of past climate shifts and a living system still changing before our eyes. Its memory is etched into desert sands, yet its waters still ripple with life. It stands as a reminder that inland seas can vanish, that what seems permanent may shrink to a shadow, and that the traces of vanished waters can endure long after the waves have gone. In the high desert of Utah lies the echo of a vanished inland sea. Today, the land feels stark and dry, a place of sagebrush, dust, and silence. Yet during the last ice age, this basin was drowned beneath the waters of Lake Bonneville, a giant freshwater lake that stretched across valleys and mountains, so large it covered nearly a third of Utah. It rivaled the size of the Caspian Sea and reached depths of more than 1,000 feet. To stand on its ice age shore would have been to gaze across a horizon of water so vast it seemed endless, shimmering under skies heavy with glacial clouds. Lake Bonneville formed when the world's climate was colder than today, and the balance of rainfall and evaporation tipped in favor of water. Snow piled high in the Rocky Mountains, and meltwater poured into Utah's closed basins. With no outlet to the ocean, the water pooled and rose, filling every low valley. For thousands of years, storms swept in from the Pacific, feeding the lake until it grew into a true inland sea. Its waves lapped against the foothills, its depth drowned entire valleys, and its shoreline curved around the edges of mountains that are now bare and sun-bleached. The Ice Age world around Bonneville was alive with creatures now lost to time. Mammoths grazed the grassy plains at its edge, leaving trails in the soft earth. Herds of bison moved across the valley floors, pursued by saber-toothed cats. Giant ground sloths, lumbering and slow, browsed on the vegetation that grew along the lake's wetlands. Above them, great flocks of birds wheeled over the water, and in the depths, fish thrived in the cool, nutrient-rich waters. Where there is now arid desert, there was once abundance. But the story of Bonneville was never static. As the Ice Age waned, the balance began to shift. The glaciers that had locked up so much water melted, rainfall patterns changed, and evaporation overtook supply. Slowly, the shoreline withdrew. The lake retreated step by step, leaving behind wide benches etched into the mountainsides, known today as Bonneville terraces. These terraces, like bathtub rings around the land, mark the levels where the water once stood, visible even now to anyone traveling through Utah. Bonneville's decline was not gentle. At its peak, the lake pressed hard against a natural barrier at Red Rock Pass in Idaho. Eventually, the rising waters overtopped the pass and broke through. What followed was one of the greatest floods in North American history. Billions of gallons of water roared northward in a matter of weeks, carving deep canyons and scouring the land. The lake dropped hundreds of feet almost at once, forever changing its shape. After this catastrophic outburst, Bonneville never fully returned to its former size. What remains today is only a fragment of that great lake, the Great Salt Lake. Unlike its Ice Age ancestor, it is no longer fresh. Every river that flows into it carries tiny amounts of dissolved minerals. Because the lake has no outlet, the water evaporates, but the salts stay behind. Over thousands of years, the salinity has risen until only brine shrimp and salt-loving microbes can thrive in its waters. Yet the lake still pulses with life, providing food for millions of migratory birds that rest along its shores. Northwest of the lake lies one of the most remarkable remnants of Bonneville, the Bonneville Salt Flats. This wide, glistening expanse looks otherworldly, stretching for miles under the desert sun. The flats are not framed here as the legacy of all vanished seas, but as the specific ghost of Bonneville's retreat. When the last waters evaporated from this part of the basin, they left behind a crust of salt that hardened into a flat, dazzling plain. Under a bright sky, it seems to glow. After rain, a thin film of water turns the flats into a perfect mirror, reflecting clouds and mountains so clearly that the horizon disappears, and the desert feels like a sky turned upside down. Mirages often dance across the flats in the heat, wavering visions of phantom lakes shimmering in the distance. To early travelers, these illusions must have been haunting, as though the waters of Bonneville were trying to return, only to dissolve again into air. Even today, when modern races and records are set across the salt crust, the flats carry a silence that feels ancient, as though it remembers the waves that once rolled there. Scientists continue to study the sediments left behind by Bonneville. Cores drilled into the basin reveal layers of mud, pollen, and shells, recording every rise and fall of the lake. Within these layers are stories of changing climates, of shifting rainfall, and of sudden catastrophe. The terraces etched into the mountainsides and the flats stretching into the desert are only the visible reminders. Deep below, the sediments still keep the memory of an inland sea that came and went with the Ice Age. The ghost of Lake Bonneville lingers in every mirage that shimmers across the desert floor, in every white stretch of salt that blinds the eyes, and in every scar carved into the mountains. What is now desert once held one of the largest lakes North America has ever known. Though the waters are gone, the land still whispers of them, shimmering with reminders of an age when Utah was not dust and sage, but waves and wind. There are places on Earth where the death of a sea is not written only in stone or salt flats, but in living memory. One of the starkest examples is the Aral Sea, a body of water that only a few decades ago ranked as the fourth largest inland sea on the planet. It stretched across the heart of Central Asia, between Kazakhstan and Uzbekistan, a vast expanse of blue that nourished ecosystems, supported millions of people, and shaped the culture of entire nations. Today, most of it is gone. The Aral Sea was once a giant of the steppe, fed by two great rivers, the Amu Darya and the Sir Darya. It spread like a shimmering ocean across a desert land. From above, it looked like a handprint of water pressed into the earth, its fingers of shoreline reaching deep into the sands. Fishing villages clustered along its edges, and for centuries fleets of boats pulled in catches that seemed endless. The Aral was so abundant that it provided one of the richest freshwater fisheries in the world, with species ranging from sturgeon to perch. Its waters moderated the harsh climate of Central Asia, bringing moisture, cooler summers, and gentler winters to the region. Then, in the mid-20th century, human ambition began to alter the balance. The Soviet Union sought to turn Central Asia into a powerhouse of cotton and wheat. To feed the fields, massive irrigation projects diverted the waters of the Amu Darya and Sir Darya into canals that snaked across the steppe. Croplands bloomed, but the price was hidden. Less and less water reached the Aral Sea. At first, the retreat was slow, but within a few decades, the shrinking became catastrophic. By the 1960s, the decline was visible. By the 1980s, entire sections of the sea had dried into salt flats. By the 2000s, it had lost around 90% of its volume. What had once been a unified inland ocean split into smaller, shrinking fragments. Where fishing harbors had once bustled with activity, rusting ships now lay stranded miles from the receding shoreline, marooned on desert ground. Entire fleets were left useless, sitting at awkward angles on cracked earth that had once been seafloor. For the fishing communities of the Aral, the loss was devastating. Generations of families who had lived from the sea's bounty suddenly found themselves with nothing to catch. The villages that had thrived on the edge of the water became ghost towns. Nets rotted in abandoned warehouses. Schools and shops emptied. In some places, the desert wind carries the creak of old hulls and the crunch of salt beneath foot, where waves once rolled. The ecological collapse was equally severe. The Aral Sea had been home to dozens of species of fish, but most could not survive the rising salinity as the water evaporated. Birds that had migrated to the sea's wetlands found their habitats shrinking. The microclimate that had once moderated the region shifted. Summers grew hotter, winters harsher, and dust storms more frequent. The exposed seabed, laced with salt and pesticide residues from decades of agricultural runoff, became a new hazard. Winds lifted the toxic dust into the air, spreading it across farmland and villages, searing lungs and poisoning crops. Yet even in this devastation, scientists and local people have traced the outlines of resilience. Efforts to save the northern part of the Aral Sea, known as the North Aral, have met with some success. With the help of a dam built in Kazakhstan, water levels there have risen, and fish populations have begun to return. Once abandoned fisheries in the north are showing signs of recovery, though the southern portions of the sea remain largely beyond repair. The story of the Aral Sea is often called one of the greatest environmental catastrophes caused by humans. It is not a story written over millions of years like the vanishing of the Tethys or the retreat of Lake Bonneville. It is a story of a single human lifetime. People who remember playing on its shores as children have lived to see the sea vanish before their eyes. Photographs taken only a generation apart show the staggering transformation from water to desert. The Aral reminds us that seas can die not only through slow geological processes, but also through the choices of human societies. It stands as a living echo of what happens when rivers are redirected, when nature's balance is disrupted, and when the thirst for land outweighs the needs of water. The ghost of the Aral lies not in deep time, but in the here and now, written into the lives of people who once depended on it and who now walk across its empty floor. When the Aral Sea began to shrink, it was not only the water that disappeared. Hidden beneath the waves for centuries lay sediments laced with poisons. Once the water retreated, these sediments were no longer sealed and safe. They were left to dry under the sun, cracked and exposed, and the wind became their messenger. What had been a shield of water now turned into a source of harm, releasing a legacy of toxins across the land. The story begins decades earlier, in the middle of the 20th century, when two great rivers, the Amu Darya and the Sir Darya, carried not just water into the Aral, but the runoff of vast Soviet irrigation schemes. Cotton fields, stretched for hundreds of miles across Central Asia, dependent on heavy use of pesticides and fertilizers. To maximize yields, chemicals like DDT, lindane, and other compounds were poured onto the soil. With every rain, with every wash of irrigation water, these chemicals flowed downstream and eventually sank into the Aral's sediments. As long as the sea remained full, the poisons stayed diluted and hidden, but as the sea dried, they were left behind in bare deposits of salt, silt, and chemicals that spread across the empty seabed. This exposed ground, known locally as the Aralkum Desert, became one of the most toxic landscapes on Earth. Winds sweeping across it lifted fine dust into the sky, but this was no ordinary dust. It carried with it concentrated salt crystals, pesticide residues, and heavy metals that had accumulated over decades of farming. Each storm rose like a ghost from the seabed, drifting over villages and fields, settling into wells and coating crops. Farmers who had once drawn water from the Aral to nourish their land now saw their soil poisoned from above, a cruel inversion of the promise of irrigation. For people living around the former shoreline, the consequences have been devastating. Doctors and researchers in the region began to notice troubling patterns soon after the sea collapsed. Rates of cancers rose, particularly throat and liver cancers. Respiratory illnesses became common, with people inhaling dust that irritated and scarred the lungs. Anemia spread widely, especially among children, linked to both contaminated food and chronic exposure to pollutants. Infant mortality rates once soared to levels far above the world average, and pregnancy complications became tragically familiar. The very chemicals meant to boost agricultural production ended up cutting deeply into human health. The poisoned winds did not stop at the boundaries of the old sea. Carried high into the atmosphere, they reached far into Central Asia. Villages hundreds of miles away reported increased dust and soil contamination. Some scientific studies have even found traces of aral pesticides in distant mountain snow, proof that these winds traveled far before releasing their load. Though less dramatic than the vanishing of the sea itself, this spread of invisible toxins turned the Aral from a regional tragedy into a story of how interconnected water, air, and human activity can be. Daily life around the Aral changed in profound ways. Farmers often found their fields coated in white crusts of salt and chemicals, making it difficult to grow crops. Wells that once gave clean water were tainted by pollutants that seeped down from the dried seabed. Livestock weakened or died after grazing on contaminated plants. Families who had lived by fishing and farming for generations found themselves stripped of both livelihoods at once, first by the sea's disappearance and then by the poisoned winds that followed. Even ecosystems suffered in ways that echoed far beyond the shoreline. Once the Aral supported thriving wetlands at its edges, rich with fish, birds, and reeds. As the waters shrank and the toxins spread, those wetlands withered. Birds that relied on them for migration lost safe stopovers, and fish populations collapsed under the combined pressures of salinity and chemical contamination. The poisoned seabed was not just barren, it was actively hostile to life. Efforts have been made to soften this legacy. In some parts of Kazakhstan, reforestation projects have planted hardy saxaul trees to stabilize the soil and reduce the spread of toxic dust. The North Aral, partially revived by the construction of a dam, has seen some return of fish and water birds. These are signs of hope, but they are small compared to the vast wound left behind. The southern basins of the Aral remain dry, their seabeds stretching as a pale scar visible from space, continuing to send their poisoned breath across the steppe. The haunting truth is that the Aral's waters once acted as a shield. While the sea existed, it locked away decades of human negligence, keeping those toxins underwater where they could do less harm. When the sea disappeared, that shield was broken and the poisons were set free. Each storm over the Aralcombe Desert is not simply a weather event, but a reminder of choices made long ago, choices that turned a sea into a desert of chemicals. The poisoned winds of the Aral tell a sobering story of how fragile the balance can be between human ambition and the natural world. In trying to force the land to yield more cotton, an entire sea was drained, and the very air became dangerous to breathe. It is a story of a ghost sea that continues to harm the living, its absence as destructive as its presence once was nurturing. The Dead Sea has always seemed timeless, a body of water so strange and otherworldly that it feels like it belongs to a different planet. It sits at the lowest exposed point on Earth's surface, more than 1,000 feet below sea level, cradled in the Jordan Rift Valley between Israel, Jordan, and Palestine. Its surface gleams like polished glass, a heavy liquid where no fish swim and no reeds grow. For centuries, travelers have marveled at its silence, floating effortlessly on its dense waters, the salt stinging their skin, the air hot and dry. But the stillness of the Dead Sea hides a story of rapid change, for this ancient lake is shrinking at a speed that shocks scientists and locals alike. Unlike the vanished seas of the distant past, the Dead Sea's retreat is happening in real time, unfolding within a single lifetime. The waters that once fed it, rivers like the Jordan, have been diverted for irrigation and drinking supplies. Dams, canals, and pumping stations now intercept the flow that once poured steadily into the basin. Without this steady replenishment, the desert sun drinks more water from the surface than the rivers can replace. Each year, the sea level drops by more than 3 feet, a pace so swift that it leaves behind exposed shorelines that change shape with startling speed. Where once villages stood close to the water's edge, the shore has retreated by miles. What used to be beachfront now lies stranded as barren flats of salt and mud. To walk toward the water today is to cross ground that, not long ago, was submerged under its shimmering surface. The silence here is pierced by crunching crystals beneath the feet, sharp and brittle, forming delicate white layers that crackle like broken glass. These salt crystals are not only beautiful, they are markers of absence, each one a quiet testimony to the water that has slipped away. But perhaps the most unsettling signs of the Dead Sea's retreat are the sinkholes. As the water level drops, underground aquifers shift and hidden pockets collapse. Across the shoreline, the earth suddenly gives way, opening chasms where orchards, roads, and even buildings once stood. Some sinkholes yawn wide enough to swallow entire date palm groves. Others form overnight, leaving behind ragged edges of soil and a hollowed space where the land simply fell into itself. Scientists count thousands of these sinkholes now, spreading along the receding shore, making parts of the coastline dangerous and unpredictable. These sinkholes are more than geological curiosities. They disrupt livelihoods, forcing farmers and communities to abandon fields and homes. They tear apart roads that once led to the water's edge, isolating towns that once relied on visitors. For centuries, the Dead Sea was not only a natural wonder, but also a place of commerce and pilgrimage. Salt, bitumen, and minerals were harvested from its waters, and its stark landscape became a symbol in scriptures and stories. Now, the very ground that carried those traditions is giving way beneath human feet. As the waters shrink, something else emerges. Along the retreating edges, brilliant formations of salt are revealed, twisting into strange shapes that catch the sunlight and glow like sculptures. Some are delicate spires, others are sheets that look like frozen waterfalls. These salt growths give the place an eerie beauty, as if the shoreline itself were crystallizing. But they are also reminders of imbalance, a frozen record of a sea that is drying faster than it can replenish. The Dead Sea's retreat also has consequences beyond its own basin. Scientists warn that the decline alters regional weather, shifting how moisture moves in the atmosphere. The loss of water surface reduces local humidity, affecting rainfall patterns. As the shoreline pulls back, dust storms rise from the exposed flats, carrying fine salt particles into surrounding valleys. These winds sting the eyes and parch the lungs, adding yet another hardship to those who live nearby. Efforts to slow the retreat have been proposed, including ambitious projects to channel water from the Red Sea or the Mediterranean. Such plans carry their own risks, as mixing waters of different chemistry could alter the delicate balance of this hypersaline lake. For now, the Dead Sea continues to shrink, its surface falling lower each year, its once continuous expanse breaking into smaller pools and bays. To stand on its edge today is to feel the weight of deep time compressed into the present. In the distance, the surrounding cliffs glow red in the desert sun, their faces carved by ages of erosion. At the feet of those cliffs, the water glimmers, but it is further away than memory recalls. The air is thick with heat, the shoreline littered with salt crystals that shine like scattered jewels. Yet behind the beauty is a silence that carries unease, as if the sea itself is slipping away before our eyes. The Dead Sea is not yet gone, but its retreat is a reminder that even the most enduring waters are fragile. Unlike the vanished oceans of prehistory, this one disappears not because of tectonic shifts or ancient climate swings, but because of choices made in the modern age. It is a drying sea of today, a place where the boundary between natural wonder and human impact is starkly visible. When seas disappear, they often leave behind more than barren ground. Their silence is deceptive, for what follows is not stillness, but movement. The exposed beds of vanished waters can transform into engines of dust, sending vast plumes into the sky. What once lay hidden beneath calm waves is suddenly set loose on the wind, rising into the atmosphere and traveling distances that link continents together. A Dead Sea, it seems, does not simply vanish, it exhales. The surface of an exposed seabed is fragile and unstable. At first glance, it may appear solid, a crust of salt glinting under the sun, with stretches of clay and sand between the pale patches. But this crust is delicate, cracking easily and crumbling into grains so fine that even the lightest wind can lift them. Once airborne, these particles do not fall quickly. They rise into billowing curtains, shifting colors from pale gray to copper to an almost storm-black haze that dims the horizon. For those who live nearby, the air thickens, breathing becomes heavier, and the sound of the wind carries the dry rasp of a vanished sea. This process has unfolded in many places across Earth, both in the past and in the present. The exposed basins of seas like the Aral or the shrinking remnants of the Dead Sea provide striking modern examples, but the phenomenon itself is far older. During the Messinian Salinity Crisis, when the Mediterranean nearly evaporated around 6 million years ago, its desiccated floor became a source of massive dust plumes. Geologists drilling deep into ocean sediments have discovered layers of fine particles from that time, confirming that storms born from vanished waters once drifted far beyond the basin's edge. The Paratethys, too, left behind its own dust signature across Eurasia, though the details differ from the Aral's modern catastrophe. Its exposed plains provided vast surfaces of fine sediment lifted into the air during dry seasons. These events were not isolated or rare. They were rhythms in Earth's climate, pulses of dust tied to the retreat of seas. Each sea that dried carved its mark not only into landscapes of salt and clay, but also into the geological memory of the planet. Scientists study these memories in the form of sediment cores, pulled from the depths of oceans or the layers of ancient lake beds. These slender cylinders of stone preserve a layered archive. Within them, dust appears as faint but distinct bands, sometimes only a few millimeters thick, that contrast with darker muds or lighter silts. Each band tells of a moment when winds carried particles far from their source and allowed them to rain gently onto distant waters. By analyzing the minerals within these bands, researchers can trace them back to vanished seas or drying basins. The chemical fingerprints reveal whether the dust came from salt flats, desert sands, or soils that once lay beneath waves. The journey of dust does not stop at the edge of a dried sea. Carried high into the atmosphere, these particles can drift for thousands of miles. Saharan dust today, for example, crosses the Atlantic Ocean, feeding the soils of the Amazon rainforest with phosphorus. In a similar way, dust from ancient vanished seas may have altered ecosystems far from their shorelines. Some plumes may have carried nutrients, while others carried poison, depending on the chemistry of the exposed seabed. It is a reminder that the fate of an inland sea can ripple outward, touching distant lands through invisible threads of air. The consequences are not only ecological, but also climatic. Dust interacts with sunlight, scattering it in ways that cool some regions while warming others. It changes how clouds form, sometimes suppressing rainfall, sometimes seeding storms. Over long timescales, these shifts can alter monsoon patterns, drive deserts to expand or contract, and even influence the advance and retreat of glaciers. Sediment records show that great pulses of dust often coincided with major changes in Earth's climate, as if the drying of seas was both a symptom and a driver of broader environmental upheaval. For human communities, the impact of dust storms from dead seas is immediate and personal. Fine grains work their way into lungs, aggravating asthma and other respiratory diseases. They coat crops, damage soils, and corrode metal. Farmers may wake to fields covered in a pale layer that chokes roots and depletes fertility. Children grow up breathing air laced with the ghosts of vanished waters. In these storms, the absence of the sea becomes tangible, not as silence, but as a force carried into every breath. And yet there is a paradox in this story. Dust, for all its dangers, is also a carrier of life. Nutrients locked in sediments can be spread to new soils, feeding plants oceans away. Some scientists believe that without the long history of dust plumes, ecosystems like the Amazon might never have reached their extraordinary richness. The same process that once turned drying seas into deserts also carried their minerals across the globe, weaving connections between distant worlds. To think of a sea reborn as dust is both unsettling and awe-inspiring. A body of water that once held fish, whales, and reefs may, long after it dries, rise again into the sky, scattering its memory across mountains, rivers, and forests. In the fine grains captured in sediment cores, in the hazy skies above deserts, in the soils enriched far from their origin, the whispers of vanished seas remain. A dead sea is never truly gone. It lingers in the air, carried on winds that tie past to present, silence to storm. When bodies of water retreat, they do not vanish without leaving their mark. What remains behind is one of the most enduring substances on Earth: salt. At first glance, it seems ordinary, scattered on dinner tables and dissolved in oceans. But in truth, each grain is a crystallized echo of water that no longer exists. Salt is both a physical remnant and a chemical archive, a mineral script that records the rhythms of evaporation and loss. The grandest example of this legacy can be found in Bolivia, in the Salar de Uyuni, stretching across more than 4,000 square miles. It is the largest salt flat in the world. What now glitters under the Andean sun was once a massive ice age lake known as Lake Minchin. As climates shifted and water evaporated, the lake withdrew, leaving behind a crust of salt so expansive and so perfectly flat that satellites today use it to calibrate their instruments. During the rainy season, a thin layer of water spreads across the surface, and the flat transforms into a mirror of sky. For a few brief weeks, horizon and heavens vanish, replaced by an endless reflection, as though the lost waters are trying to reappear. Beneath the surface of Salar de Uyuni lie thick brine reservoirs rich in lithium. These brines are the chemical concentration of vanished water, minerals drawn from the land by streams and locked in place as the lake dried. Now they form one of the planet's most important sources of lithium, the element that powers batteries in phones, computers, and electric vehicles. In this way, an ancient sea that disappeared tens of thousands of years ago still drives human technology, connecting the past to the present in the most unexpected of ways. Other salt flats across the world carry similar stories. In California's Death Valley, the Badwater Basin gleams with a white crust of salt left by the evaporation of Lake Manly, a deep freshwater body that filled the valley during the Ice Age. Standing there today, with temperatures soaring and heat pressing down like a physical weight, it is almost impossible to imagine waves rolling across this desert floor. Yet every crystal crunching beneath a traveler's feet is a remnant of those waters. On the far side of the world, the Danakil Depression in Ethiopia presents a harsher vision. Here, salt is not just flat crust, but an alien landscape shaped by heat, tectonics, and chemistry. Pools of acid shimmer in vivid yellows and greens, salt terraces rise like staircases, and pillars of white stretch across plains where no plant grows. These features are born from ancient lakes and seas, drying beneath relentless desert sun. The minerals left behind do not rest quietly. They react, ferment, and rise into forms that look more at home on another planet than on Earth. In Africa's Makadikgadi Pan in Botswana, one of the largest salt pans on Earth, the story is the same. Once part of a great lake that rivaled modern inland seas in size, it is now a shining desert floor stretching beyond sight. During rare rains, the pan comes alive, filling with shallow water that attracts flamingos in the thousands. Their sudden arrival transforms the silence into a living spectacle, a brief return of life to a place defined by absence. What makes salt unique among Earth's legacies is that it is not just scenery, but a record. Chemically, salt crystals can trap tiny bubbles of the water from which they formed. Within these inclusions, scientists can study the chemistry of vanished seas, their salinity, their temperature, even the microbial life that swam within them. Some halophilic, or salt-loving, microbes have been found preserved inside crystals for tens of thousands of years, still alive in microscopic suspension. A handful of salt can therefore hold not just the memory of water, but the remnants of life itself. Salt also carries a cultural memory. Humans have followed salt since prehistory, mining it from ancient seabeds and trading it across continents. Roman soldiers once received part of their pay in salt, the root of the word salary. In the Sahara, caravans carried blocks of it across burning sands, shaping trade networks that connected distant empires. Every block carved, every grain scattered, is a fragment of a sea long vanished, transformed into currency, food, and survival. What unites all these examples is the way salt testifies to change. A lake may vanish, an ocean may dry, but the crystals remain, glittering under the sun or buried deep within the earth. They are reminders of instability, of the fragile balance between water, air, and climate. When modern lakes like the Dead Sea or Lake Urmia retreat, they too leave crusts of salt behind. In the centuries to come, these crusts may join the global family of salt flats, landscapes born not of growth, but of retreat. Salt, then, is not only a legacy, but a warning. It speaks of waters that once seemed permanent, of ecosystems that thrived and then collapsed, of cycles of wetness and drought repeated across the ages. To walk across a salt flat is to tread on a history written in crystals, a record of seas that surrendered to the air. It is Earth's way of telling us that nothing, not even water, lasts forever. When ancient seas vanished, they often left behind strange reminders. Salt flats, dust storms, and poisoned winds told the story of waters retreating. Yet not all of these hostile landscapes belong to the distant past. Even today, there are lakes that echo the deadly chemistry of vanished seas, places where water still lingers, but carries within it the ability to kill instead of nurture. They are reminders that even something as simple and familiar as a lake can become an environment so extreme that life itself is trapped, calcified, or erased. One of the most haunting examples lies in East Africa. Lake Natron in northern Tanzania appears from a distance like a sheet of crimson glass, its surface glowing red and orange under the heat of the sun. The colors come from salt-loving microorganisms and algae that thrive in its extreme chemistry. Beneath this deceptive beauty is a world of lethal water. The lake is fed by mineral-rich hot springs and sits in a region of active volcanism, and as the water evaporates under the desert sun, it becomes saturated with sodium carbonate and other salts. The result is an alkaline brine, so caustic that it can strip flesh from bone. Temperatures near the shore can climb higher than 100 degrees Fahrenheit, making the shallows more like a simmering cauldron than a refuge. Birds sometimes crash into the surface, disoriented by its reflective sheen, and their bodies become coated in the mineral-rich water. Over time, they calcify into statues, frozen in lifelike poses. Photographers have found entire flocks of small animals preserved in this way, their outlines hardened into stone-like forms, as if turned to statues by a mythic curse. The effect is unsettling yet strangely beautiful, a reminder of how chemistry can sculpt nature into art while ending the lives it touches. Lake Natron, however, is not empty of life. In its shallows, lesser flamingos gather in the hundreds of thousands to breed, feeding on the very algae that gives the water its color. Their long legs and specialized bills allow them to live on the edge of conditions that kill most other creatures. It is a paradox. The lake that kills also provides sanctuary because predators dare not follow. This duality mirrors the ancient seas of Earth, where waters that suffocated some creatures created niches for others. Elsewhere in Africa, other lakes hold similar dangers. Lake Kivu, straddling the border of Rwanda and the Democratic Republic of Congo, looks serene on the surface. It is deep and clear, surrounded by green hills, but hidden in its depths is a vast reservoir of carbon dioxide and methane, trapped by the pressure of the heavy water above. If disturbed, these gases could erupt in what scientists call a limnic explosion. When this happened at Lake Nyos in Cameroon in 1986, an invisible cloud of carbon dioxide poured across the landscape, suffocating more than 1,700 people and countless animals in the valleys below. Lake Kivu holds thousands of times more gas, enough to threaten millions of lives should the balance tip. What looks peaceful is, in truth, a silent bomb. Smaller lakes across the world echo the chemistry of ancient seas as well. In Ethiopia's Danakil Depression, lakes shimmer with colors that seem unreal, stained yellow and green by sulfur and heavy with acid. These pools are so corrosive that they dissolve metal and burn skin, yet extremophiles, tiny microorganisms, still cling to survival within them. Such conditions resemble early Earth, when the oceans were thick with minerals and oxygen was scarce. To walk near these waters is to glimpse conditions that may have shaped the origins of life itself. Even in Europe, toxic lakes exist, often born of human industry. Old mining pits, filled with rainwater, can become acidic basins where metals leach from stone, staining the waters with hues of red or turquoise. In Spain's Rio Tinto, a river that flows like liquid rust, microorganisms survive by feeding on iron and sulfur, creating a landscape that resembles photographs of Mars. Here, science looks to toxic waters not only as dangers, but as analogues for other worlds, places where life might exist in conditions once thought impossible. The lesson of these lakes is that danger and beauty often coexist. Their surfaces glisten under the sun, and their colors draw the eye like jewels, but within them lies chemistry that recalls mass extinctions and suffocating seas. They remind us that water, while essential, is not always kind. Depending on its chemistry, it can cradle life or seal it in stone. The calcified birds of Lake Natron, the suffocating fogs of Lake Nyos, and the bubbling acid pools of Ethiopia all mirror the hostile episodes of Earth's history when seas turned against the creatures that lived within them. These modern toxic lakes are not merely curiosities, they are laboratories of survival, teaching scientists how life endures on the edge of possibility. They are also warnings, showing us how delicate the balance of water and chemistry can be. Just as inland seas once vanished or poisoned themselves into silence, the lakes of today may one day dry, leaving behind only salt, dust, and fossils of the creatures that strayed too close. The story of seas vanishing is written not only in salt flats and stranded ships, not only in fossil whales or giant canyons cut by retreating rivers. It is also written in secrets, so small that they can rest unseen on the head of a pin. These are the microfossils, the tiniest witnesses to Earth's changing waters, whose shells and skeletons carry the record of vanished oceans in delicate detail. When we picture fossils, we often imagine the skeleton of a dinosaur rising from desert cliffs, or the petrified bones of marine reptiles locked in stone. Yet beneath the gaze of the naked eye lies a different archive, one that holds a memory far older and often more precise than any great skeleton. Foraminifera, diatoms, and tiny plankton built shells of calcium carbonate or silica as they floated in ancient seas. When they died, their microscopic bodies drifted downward, settling layer by layer into seabeds. Over millions of years, Those layers hardened into rock, forming a library where each page is no thicker than a grain of sand. Inside these pages, salinity is recorded like ink. When seawater grew saltier under evaporation, microfossils built shells, enriched with certain isotopes of oxygen and carbon. When fresh water poured in from rivers or melting glaciers, the chemistry shifted again, etched into the shells of the creatures that lived in those moments. It is as if the smallest of animals took notes in real time, quietly recording the changes that reshaped entire continents. Scientists drilling into ancient basins often find layers where microfossils suddenly vanish. These blank pages are just as revealing as those that are full. When an inland sea became too salty, plankton could no longer survive. Their absence in the record is the fingerprint of a catastrophe. When the Mediterranean nearly evaporated during the Messinian Salinity Crisis, whole populations of microfossils disappeared from the sediment, leaving behind barren stretches that told of waters shrinking into hypersaline pools. In contrast, when the Zanclean flood reopened the Strait of Gibraltar and seawater roared back in, new communities of plankton appeared almost instantly, their shells layering the seafloor in abundance once more. Even more haunting is the precision these microfossils provide. By examining isotopes locked in their shells, researchers can reconstruct the exact temperatures of seawater millions of years ago. They can trace the rise and fall of salinity to specific centuries, sometimes even decades, within vast geological epochs. A shift in isotope ratios may reveal a season of extreme drought, or a sudden pulse of flooding rivers, or the slow creep of evaporation that took centuries to claim a sea. In these tiny shells, time is measured not only in ages but in moments. Some microfossils even preserve hints of color, pigments trapped in molecular traces, whispering of the light conditions and ecosystems that once thrived in forgotten waters. Others reveal diets, the kinds of algae they fed on, which in turn reveals what nutrients flowed through their ancient environments. Through these traces, scientists can reconstruct not only the chemistry of the seas, but the intricate web of life that once hung suspended in their depths. The badlands of North America and the salt flats of Central Asia may speak with silence, but microfossils speak with detail. They tell us not just that seas once dried, but how quickly, how chaotically, and how life struggled to respond. In Pakistan, sediments once deposited by the retreating Tethys Ocean hold layer upon layer of foraminifera, their isotopes marking the slow death of a world sea as Africa pressed northward into Eurasia. In the Dead Sea Basin, microfossils record every fluctuation of water level, every surge of salt, every breath of evaporation, like a diary of a vanishing world written one shell at a time. The study of these tiny witnesses requires patience and a sense of scale. Under a microscope, a scientist might spend hours moving through just a few grains of sediment, each grain containing dozens of shells smaller than the eye can see. Sorting them, cataloging them, measuring the isotopes locked in their walls becomes a quiet conversation with time itself. From this silence comes clarity, a timeline of how seas rose and fell, how climates shifted, how life bent under change. There is also humility in these discoveries. Vast oceans can vanish, leaving only salt and silence, but the smallest of creatures preserve their truth. They did not live long lives or leave towering skeletons, yet their collective memory stretches farther than ours ever could. In them lies the story of extinction, survival, and rebirth reduced to the scale of dust. When you think of an ocean disappearing, it is easy to imagine the roar of water rushing out, the cracking of earth, the storms of dust that follow. Yet equally important are the quiet notes of creatures no larger than grains of sand, creatures that lived and died unseen, yet remembered the moment when seas betrayed life. Their shells are not simply remnants of biology, they are history itself, crystallized in patterns so small they remind us how fragile even the largest of worlds can be. The earth remembers in ways that are quiet but unshakable. Among its most delicate yet powerful archives are the thin layers of dust that settle across the planet, carried by winds and preserved in rock and ice. To the naked eye, dust may appear fleeting, lifted by a gust and gone within moments, but over time, those grains become pages in the geological library of the earth. Pressed into stone or frozen into ice, they preserve the memory of vanished seas, shifting climates, and changing landscapes with a precision that few other records can match. When an inland sea or Great Lake dries, its floor does not vanish into silence. Minerals that once dissolved in water remain behind, ground into fine powders of salt, clay, and gypsum. Over thousands of years, wind lifts those particles into the sky and scatters them across distant valleys, mountains, and oceans. Where they fall, they settle into thin layers that become part of the sedimentary record. Over ages, as more layers accumulate above them, they are compacted into stone, sealed into a permanent archive. What once was the breath of a sea becomes the faintest line in rock, a signature of absence and change. In Greenland's vast ice sheets, scientists drill deep cores that capture hundreds of thousands of years of atmosphere and dust. Within those translucent cylinders, thin dark bands reveal moments when winds carried enormous quantities of particles from dry basins into the polar skies. Each band can be measured for its mineral content, its isotopes, even its exact source. A layer heavy with iron oxides might trace back to the Sahara, a reminder of times when ancient lakes in North Africa contracted into dust-bearing deserts. Another, richer in gypsum or halite, might signal the drying of a saline sea. These grains, trapped in ice, act as frozen whispers of vanished waters. In rock outcrops as well, dust becomes visible as fine strata. The Loess Plateau of China is one of the most striking examples. Towering cliffs of windblown dust, hundreds of feet thick, preserve more than 2 million years of shifting climate. Each faintly different layer marks a change in winds, rainfall, or the expansion of deserts across Central Asia. Within them are clues of long-vanished lakes that once dotted the landscape, their retreat marked not only in the drying of basins, but in the dispersal of their sediments into the air. A simple handful of Loess soil contains the memory of seas that no longer exist, turned into the finest powder and carried forward in time. Dust also records chemical detail with remarkable accuracy. Under a microscope, each particle is like a tiny shard of glass or crystal. Some grains bear the reddish hue of oxidized iron, testifying to the drying of seabeds under scorching suns. Others are pale white, flecked with gypsum, remnants of brines that evaporated under intense heat. Their shapes and chemistry carry fingerprints of the environments from which they came. To a geologist, a pinch of dust is not debris but evidence, a record of where the earth was wet when it grew dry, and how climates shifted in response. Ocean sediments carry these stories as well. Far from land, thousands of miles across the sea, fine layers of dust settle on the seafloor year after year. Drilled cores from the Atlantic and Pacific reveal alternating bands of plankton shells and wind-blown dust. In these, scientists detect cycles of rainfall and drought, monsoon strength, and the retreat of inland waters. The very minerals within those dust layers can be traced to specific vanished basins, proving that even when a sea is gone, its memory may linger in the depths of an ocean far away. What makes dust in the geological record so powerful is its persistence. Unlike bones or shells, which may erode or dissolve, dust settles in great volumes and spreads widely, increasing its chance of preservation. It is less dramatic than a fossilized whale in the desert or a canyon carved by vanished rivers, yet it is often more complete. It provides an unbroken chain of evidence stretching back millions of years, a continuous thread that weaves together water, air, and stone. Seen this way, dust is more than the residue of loss. It is a bridge across time, linking past climates to present ones. A layer in Greenland's ice may tell of a drought in Africa. A band in a Loess cliff may echo the drying of a Central Asian sea. Together, these records allow scientists to reconstruct not just isolated events, but long rhythms of Earth's history, the pulse of monsoons, the waxing and waning of deserts, the slow collapse of inland waters that once seemed eternal. To stand before these records is to realize that nothing on Earth vanishes without leaving a trace. A sea may disappear, its waves silenced, its life erased, yet its memory is carried aloft as dust, scattered across continents, pressed into stone, and preserved for millions of years. Each grain is a fragment of time, delicate yet indestructible, waiting in the quiet depths of Earth's archive to be read again. When a sea begins to vanish, it does not simply take its water with it. It takes with it a whole world of connections. Oceans are highways of life, channels that allow creatures to spread, migrate, and exchange genes. When those waters shrink and break into fragments, the living things within them are left stranded, cut off from the wider world. What was once an open sea becomes a chain of isolated pools, lagoons, and briny lakes. And within those shrinking waters, life either adapts or perishes. Isolation is a powerful sculptor. Imagine a dolphin trapped in a corner of the Paratethys Sea as the water receded millions of years ago. No longer free to roam across an open ocean, it was hemmed in by mountains and shallow channels. Over time, its body began to change. Some of these dolphins grew smaller, their skeletons adapting to the tighter, murkier spaces they now inhabited. Others developed unique teeth suited to prey that only lived in their restricted waters. They became endemic, existing nowhere else, living echoes of a sea slowly slipping away. Fish faced similar trials. When large seas fractured into smaller basins, whole populations were sealed into salty lagoons or freshwater lakes. Some survived by tolerating increasingly extreme conditions. There are fossils of tiny fish species that show rapid adaptations in gill size and body form. Small evolutionary experiments forced by changing salinity. Many did not survive the shift, but a few managed to hold on, their descendants carrying the mark of survival against narrowing odds. These shrinking seas created what scientists call evolutionary bottlenecks. A once diverse population would collapse into a small, vulnerable group, its genetic variety thinned by isolation. That lack of diversity carried risk, leaving species more fragile in the face of disease, climate shifts, or competition. Yet it also created opportunities for odd and unexpected creatures to arise. When the genetic deck is shuffled in a small, enclosed space, new adaptations can appear quickly. The results were often strange animals that could not have thrived in the open ocean, but within their shrunken worlds, they became perfectly suited. Some left behind fossils that puzzle scientists even today. In dried arms of the Paratethys, researchers have uncovered remains of dwarf whales and dolphins, creatures that shrank dramatically from their ocean-dwelling relatives. They were not weak versions of whales, but specialized survivors, their small size giving them an advantage in shallow and food-limited waters. Elsewhere, strange mollusks flourished in hypersaline pools where few others could endure. Their shells record the chemical stress of their environments, etched with patterns of survival in waters too salty for most. Isolation also bred vulnerability. When rivers that fed these basins shifted course or climates dried further, the last refuges could collapse suddenly. Entire species winked out in these moments, leaving behind only faint imprints in stone. The fossil record tells of ammonites, corals, and small marine reptiles that lasted longer in isolated pockets than in the wider seas, holding on until the very end before disappearing forever. Even in modern times, we can glimpse this same story playing out. Lake Baikal in Siberia, though not a sea, is a closed basin that has nurtured unique species found nowhere else on Earth. Strange transparent shrimp and the Baikal seal evolved in its isolated waters. Lake Tanganyika and Lake Malawi in Africa, born from tectonic rifts, have become laboratories of evolution, with fish diversifying into hundreds of unique forms. These living lakes show what once happened on a much larger scale when whole inland seas shrank and fragmented, forcing species down narrow paths of survival. The most haunting thought is how many experiments in life were lost. For every odd dolphin that adapted, how many perished unseen? For every fish that learned to tolerate saltier waters, how many failed? The survivors are only the tiniest sliver of the possibilities, the rest erased with their seas. What is left in stone and bone is not the full story, but fragments of resilience preserved in deep time. Isolation shaped life in profound ways. When seas vanished, their last inhabitants lived on the edge of extinction in small pockets of habitability. They endured harsh salinity, shrinking ranges, and dwindling food. Yet some persisted long enough to leave their mark, written into the fossil beds of Europe, Asia, and Africa. These survivors remind us that even as Earth takes away vast oceans, life does not always surrender quietly. It bends, changes, and reshapes itself in ways that can seem alien, as if to whisper that survival itself is a kind of creativity. Long after the seas had vanished, their memory remained not only in the silent fossils and glittering salt flats, but also in the lives of humans who would one day walk across those empty basins. Where oceans once breathed, salt was left behind, layered thick in the ground, waiting to be discovered. To ancient people, this was not merely a mineral, it was life itself. Salt preserved food, carried flavor, and became so valuable that it was often called white gold. In many ways, the bones of vanished seas nourished the rise of human civilization. Imagine the first groups of humans wandering across a barren desert floor. The land looks empty, yet under the sun, the ground sparkles with crystals of salt, remnants of a sea that had disappeared thousands of years before. To taste it was to taste survival. Meat and fish could be cured, lasting longer than a single day. Journeys could stretch across wider distances without hunger, gnawing so quickly. Families could store food for winters, for droughts, for times when the land yielded little. This was not a luxury, but a necessity, and it gave humans a new kind of freedom. As communities grew, so did the demand. Entire settlements sprang up around salt-rich areas. In the Middle East, the dry basins left behind by the retreat of the Tethys Ocean became some of the earliest salt mines. In ancient China, wells were dug deep into the earth to reach briny water, which was boiled to leave crystals behind. Across Africa, caravans marched across the Sahara Desert, trading slabs of salt cut from the ground where inland lakes had once shimmered. Camels carried the precious mineral across dunes, linking distant cultures and empires together through trails that still echo with history. Salt did more than feed the body, it fed economies. The Roman Empire taxed it, storing it in vast warehouses. Soldiers were often paid with allowances of salt, a practice that gave birth to the word salary. Roads were built to carry it, and entire towns grew wealthy from controlling its flow. In Venice, control of salt trade helped turn a city of islands into a maritime powerhouse. In Ethiopia, bricks of salt called amole were once used as currency, stacked like coins and passed hand to hand. All of these stories trace back, in a quiet way, to seas that no longer existed, their absence leaving behind the crystals that shaped human destiny. Salt routes were more than trade paths, they were veins through which civilizations pulsed. The trans Saharan routes connected West Africa to the Mediterranean, moving salt as steadily as gold. In the Himalayas, salt caravans carried loads across perilous mountain passes to feed communities in Tibet and India. In Europe, the salt road stretched across the Alps, winding from Austria to Italy, carrying blocks from mountain mines that had been born of ancient evaporated seas. These routes did not just move goods, they carried stories, languages, and cultures, weaving the fabric of the old world together. Salt also held a place in ritual and meaning. It was used in offerings, in purification ceremonies, and in medicine. Ancient Egyptians used it in mummification, preserving bodies for the afterlife. In Japan, it was sprinkled to drive away spirits. In Christianity, it became a symbol of incorruptibility and endurance. In all of these, one can trace the influence of seas long gone, their vanished waters echoing not only in trade, but in the spiritual imagination of humanity. Civilization itself was carved from these remnants. Cities like Salzburg, whose very name means salt fortress, grew wealthy on mining and trade. Empires rose in part on their control of the resource, their boundaries drawn by access to ancient seabeds rich in crystal. Even wars were fought over it, as communities sought to hold onto the lifeblood of preservation and prosperity. Without salt, armies could not march far, populations could not grow large, and cultures could not endure in harsh climates. The bones of dead seas shaped more than landscapes. They shaped the course of human history. Every slab of salt cut from the ground was a fragment of an ancient ocean, carried forward through time into kitchens, caravans, and temples. Each grain, once part of a living sea, became part of our own story, a quiet thread linking prehistory to the rise of empires. And so, the vanished seas lived on, not through waves or tides, but through the hands of humans who mined their memory. The same waters that once drowned continents continued to sustain life, even in absence, their power stretching across ages and civilizations. When seas vanish, they do not disappear only from the land, they linger in memory, in the words people whisper around fires, in the stories that are carried from one generation to the next. Long before geology explained evaporite deposits or dust storms from dry seabeds, humans were already recording these changes in the form they understood best in myth and legend. Every culture has its tales of waters that came and went, of floods that drowned worlds, and deserts that swallowed once fertile lands. These stories are not always literal, but they carry echoes of truths older than writing. They hold fragments of the times when inland seas dried, rivers shifted, and coastlines moved farther away than anyone could follow. One of the most famous stories comes from Mesopotamia, the land between the Tigris and Euphrates rivers. Here, clay tablets describe a great flood that destroyed nearly all of humanity, sparing only a chosen survivor who built a boat. This tale, Written in the Epic of Gilgamesh, is thousands of years old, yet it parallels the biblical story of Noah's Ark. Could such accounts be distant memories of real floods? Geological evidence suggests that sudden shifts in rivers and seas in this region may indeed have inspired such stories. A dried or flooded basin could feel like the end of the world to those who depended on it. Farther west, in Greek mythology, the story of Deucalion and Pyrrha tells of a flood sent by the gods to cleanse humanity. Afterward, the land was left barren and salted, a detail that resonates with the very real landscapes of Greece and the Mediterranean, where salt flats shimmered after waters receded. To an ancient observer, a plain encrusted with salt crystals might easily be read as land cursed by divine hands. In the deserts of North Africa, oral traditions speak of a time when the Sahara was green. For many generations, stories were passed down of rivers, lakes, and animals that no longer existed. When scientists uncovered fossils of crocodiles, hippos, and fish beneath the sand, they realized that these legends were not fantasies, but cultural memories of a landscape transformed by shifting climate. What was once savanna became desert, but the people who survived the change carried the memory of vanished waters with them in song and story. Even in Central Asia, echoes remain. Communities living near the Aral Sea, long before its modern collapse, spoke of the water as a living, breathing entity. They believed it could retreat as easily as it could flood, a belief that would later prove prophetic. When the sea began to shrink in the 20th century, the event felt less like an unprecedented disaster and more like the fulfillment of an ancient warning. Salt wastelands themselves also fed into myth. In regions where seas had evaporated, leaving glittering plains of salt, people often spoke of curses. These lands were lifeless, and to ancient eyes, that lifelessness needed explanation. In the Old Testament, the story of Lot's wife being turned to a pillar of salt may carry echoes of this imagery. Entire landscapes could be seen as places touched by punishment, transformed into barren expanses where life could not return. Beyond floods and deserts, the memory of seas also seeped into cultural rituals. In many traditions, salt became a symbol of purity, incorruptibility, and protection. Sprinkling salt to ward off spirits or to bless homes might be traced back to the deep cultural association between salt and survival. Without seas vanishing, leaving their crystalline bones behind, humanity might never have elevated salt into symbol. What is striking is how consistent these themes are across the globe. Whether in South America, where stories describe great waters retreating and mountains rising, or in Asia, where legends of dragon kings speak of seas withdrawing in anger, there is a recurring rhythm. Water comes, water goes, and life is forced to adjust. The details differ, but the heartbeat of the story remains the same. These myths are not precise geological records, yet they hold emotional truths. When a family stood on ground where their ancestors once fished, only to see it dry and crack beneath their feet, that loss would not be forgotten. It would be remembered in stories of gods, of punishments, of miracles, and of mysteries. Oral traditions allowed those memories to leap across centuries, long after the physical sea had vanished. Today, scientists read the layers of salt and stone to uncover the past, but perhaps the ancients already knew what those signs meant in their own way. They may not have spoken of tectonic plates or orbital shifts, but they understood that Earth itself was restless, and that water was never as eternal as it seemed. Their myths carried that warning, dressed in symbols, waiting for us to hear it again. When seas disappear, the loss is not only local. Water shapes the breath of the planet, carrying heat, feeding clouds, and steering winds. To watch a sea dry up is to watch the delicate machinery of climate lose one of its vital gears. Across deep time, whenever inland seas retreated, the air itself shifted, and the rhythms of rain and drought were rewritten. Imagine standing on the edge of a great basin when it still shimmered with water. Evaporation would rise like a ghost into the sky, carrying moisture into passing winds. Rain would fall hundreds of miles away, nourished by the breath of that single inland sea. When the waters pulled back, those rains faltered. Entire regions downwind became drier, rivers thinned, and forests gave way to grasslands. The change was not only visible in the empty seabed, but also in the skies above and the lands far beyond the horizon. The retreat of the Paratethys, sea across Europe and Asia, offers a clear example. When it stretched vast and unbroken, it fed monsoons that watered grasslands and forests as far as Central Asia. As it dwindled, those monsoons weakened. Grasslands began to thin, deserts expanded, and species that once thrived on abundant rainfall were forced to adapt or retreat. Even in places far from its shores, the drying of the Paratethys altered weather patterns, like a pebble dropped into a pond whose ripples spread outward in unexpected ways. The same story echoes in Africa, when ancient lakes and seas once filled the Sahara. Rains were more plentiful. Savannas stretched across what is now barren desert, and hippos, crocodiles, and even early humans thrived near their waters. As orbital shifts and warming patterns caused those lakes to shrink, rainfall patterns changed. Monsoons weakened, and the Sahara transformed into the vast dry expanse we know today. Dust carried from its empty basins traveled on winds, crossing oceans and settling as far away as the Amazon rainforest, fertilizing it with minerals. A vanished sea in Africa thus helped feed forests in South America, a reminder that climate is never confined by geography. Closer to our own time, the drying of the Aral Sea has given scientists a living experiment in how shrinking waters disturb weather. In the mid-20th century, when the sea still stretched wide, its surface cooled summers and softened winters. It acted as a stabilizer, holding heat and moisture like a great lung. As it collapsed to a fraction of its size, local temperatures grew harsher. Summers became hotter, winters colder, rains weaker. Winds picked up exposed dust and pesticides from the seabed, darkening skies and worsening drought in the lands that once bordered its shores. The climate around the Aral Sea shifted within a single lifetime, proof that the retreat of a sea can bend weather in sudden and unsettling ways. Scientists study the chemical traces in ancient sediments to map these changes across time. Pollen grains reveal how vegetation shifted when rainfall faltered. Dust layers show how storms grew more frequent as dry seabeds were exposed. Even isotopes locked in microfossils whisper of salinity and temperature, linking ocean retreat to global climate change. The message in every layer is the same. Seas are not passive features of the earth. They are engines of balance, and when they vanish, that balance is undone. The connection between seas and monsoons is especially striking. Large bodies of water draw in heat slowly and release it just as slowly, creating steady winds and rains. When inland seas vanish, land heats quickly and cools quickly, destabilizing the rhythm. Monsoons that once came like clockwork become erratic, sometimes vanishing altogether. The drying of seas in Central Asia, for example, altered the strength of the Indian monsoon, changing the fates of people and ecosystems far from the original water's edge. These stories of vanished seas are not only windows into the past but also quiet warnings for the present. As climate warms today, lakes are shrinking, glaciers are retreating, and seas are threatened by changing currents. The Caspian Sea is already receding. Lake Urmia in Iran has nearly collapsed. The Dead Sea retreats year by year. Each one is more than a local tragedy. Each is a thread in the wider fabric of climate, and as those threads fray, the pattern of weather unravels. In every age, the drying of seas has left behind deserts, dust storms, and altered rainfall. It has shifted winds that feed crops, forests, and entire civilizations. What once happened slowly over thousands of years is now unfolding in decades. The Earth's memory, written in salt and dust, tells us that water shapes more than shorelines. It shapes the sky itself, the soil beneath our feet, and the fragile line between survival and collapse. Across deep time, seas have risen and fallen, shaping continents and erasing worlds. Yet in the past, these changes stretched across thousands or even millions of years. Today, in the span of a single lifetime, we are watching seas shrink before our eyes. Nature once worked slowly, guided by tectonics and climate cycles. Now, human hands are pressing fast forward, and bodies of water that once seemed timeless are slipping away within decades. The Caspian Sea, the largest inland body of water on Earth, lies at the heart of this story. It is larger than many true seas, yet it has no outlet to the ocean. For thousands of years, its size has swelled and shrunk with climate shifts, fed mainly by the mighty Volga River. But modern changes are not like those of the past. Rising temperatures increase evaporation, while dams and diversions upstream capture water before it can reach the Caspian's basin. Scientists estimate that within the next century, the Caspian may drop by several dozen feet, exposing vast stretches of seabed. Cities and ports built along its shores would be left stranded, and ecosystems finely tuned to its brackish waters could collapse. Southwest of there lies the Dead Sea, a body of water famed for its density and salt. For centuries, pilgrims and travelers have floated on its surface, marveling at its buoyancy. Yet year by year, its shoreline recedes. The Jordan River, once its main lifeline, is now heavily diverted for agriculture and drinking water. Industrial extraction of minerals from its waters has also deepened its decline. The result is a retreat so rapid that maps struggle to keep pace. In the exposed ground around the shrinking sea, sinkholes open like sudden wounds. Whole stretches of land collapse without warning as underground salt dissolves away, leaving the surface hollow. What was once a place of marvel is now also a place of unsettling transformation. Farther east in Iran, Lake Urmia tells a similar story. Once one of the largest salt lakes in the world, its waters glittered in hues of turquoise and crimson, colored by algae and salt-loving microorganisms. In the 1,990 seconds, it covered thousands of square miles. But over just a few decades, dams and irrigation projects diverted the rivers that once nourished it. Combined with rising temperatures, the lake shrank to less than 10% of its original size. Fishing collapsed, bird migrations faltered, and communities that had lived along its shores for generations faced economic ruin. Dust storms began to rise from its exposed bed, laced with salt and chemicals, carried across the region to sting lungs and wither crops. These stories feel eerily familiar. They echo the vanished seas of deep time, the Paratethys, the western interior Seaway, the drying lakes of the Sahara. Yet the scale is different. Where Earth once worked in geologic time, we are now watching in human time. What once took thousands of years is now happening in less than 100. The question is no longer whether seas can vanish. It is whether they will vanish while we are still here to see it. The causes are layered. Climate change warms the air, quickening evaporation. Rivers are diverted to feed farms and cities, leaving little behind for the basins they once filled. Industrial projects mine minerals from waters already shrinking. Each pressure alone might not be enough to drain a sea so quickly, but together they create a force that overwhelms the natural cycle. Where once there was balance, now there is collapse. The danger is not confined to the waters themselves. As seas shrink, their absence reshapes weather. Rainfall shifts, dust rises, temperatures swing more wildly between seasons. Communities that once thrived on fishing or tourism see livelihoods vanish. Ancient cultural ties to these waters begin to fray as younger generations grow up beside shorelines that retreat year after year. In some places, abandoned boats rest tilted on sand, their hulls cracking in the sun, haunting reminders of a sea that no longer exists. Scientists warn that more inland seas may follow this path. The Caspian, the Dead Sea, and Lake Urmia are not isolated tragedies. They are signals of what happens when human use and climate change collide with fragile hydrology. Could seas vanish again within our lifetimes? The evidence suggests they already are. For people alive today, this is not a story of distant ages, but of unfolding present. These modern seas carry with them the same warnings written by their ancient ancestors. The earth remembers the loss of water, and so does the sky. Each retreat is more than an environmental shift. It is a rewriting of climate, of culture, and of life itself. Seas may appear eternal, stretching blue to the horizon as if nothing could erase them. Yet history and geology tell another story. Oceans and inland seas are fragile, their existence shaped by forces that lie both above and below the surface. When those forces tilt out of balance, waters retreat and whole worlds vanish. The story of why seas disappear is written not only in salt and stone, but also in the slow and restless machinery of Earth itself. At the deepest level, tectonic plates guide the fate of water. The continents are not fixed, but drifting rafts of rock that grind, collide, and separate. When plates pull apart, low basins open, and seas flood in to fill the space. The birth of the Atlantic Ocean, for example, came when the supercontinent of Pangaea cracked apart, creating room for water to rush in. But when plates collide, the opposite can happen. A sea may be squeezed shut, its floor lifted into mountains, its waters drained into other basins, or simply evaporated. The Himalayas and the deserts of Central Asia were born from such a collision when the vast Tethys Ocean was slowly choked and erased. Even smaller inland seas live at the mercy of shifting land. A narrow strait can act like a valve, controlling whether water flows in or is cut off. When the Strait of Gibraltar closed nearly 6 million years ago, the Mediterranean became a sealed basin. With no fresh supply of water from the Atlantic, it evaporated under a hot sun until most of the seafloor lay bare, crusted in thick salt. Only when the strait reopened in a cataclysmic flood did the basin fill again. Such stories remind us that a single doorway of stone can determine whether an entire sea survives or dies. Above the surface, the atmosphere plays its own role in the balance. Water cycles endlessly between sea, sky, and land, carried upward as vapor and returned as rain or snow. If the climate tips warmer, evaporation intensifies. Inland seas without strong inflows begin to shrink, their surfaces shimmering away into the air. In cold ages, the opposite can occur, with glaciers locking water on land and seas falling worldwide. In both cases, climate acts as a master lever, able to transform coastlines and basins with changes in temperature and rainfall. Evaporation is especially powerful in enclosed basins. Without rivers large enough to replace what is lost, water levels drop steadily. Salinity rises as minerals concentrate, and ecosystems grow stressed. Eventually, only salt-crusted flats remain, shining like mirrors under the sun. Places such as Lake Urmia, the Dead Sea, and the Aral Sea are living examples of how quickly this process can move when human use joins natural evaporation. Their stories echo the same physics that once emptied entire oceans. Geology also leaves behind telltale signs of vanished seas. Thick layers of evaporite minerals record ancient drying events stacked like pages of a history book. Ripple marks in stone capture the last lapse of retreating waves. Fossilized shells reveal sudden shifts in salinity, their tiny forms warped by stress. Each clue shows that seas are not erased suddenly, but through a sequence of pressures, each step pushing water closer to disappearance. The balance of water on Earth is far more delicate than it seems. Our planet's oceans hold vastness, yet their volume is finite. Less than 3% of Earth's water is fresh, and much of that is locked in ice. The thin film of liquid that supports life is fragile, vulnerable to both slow tectonic drift and rapid climate swings. A slight change in temperature, rainfall, or land elevation can determine whether a basin flourishes as a sea or shrinks into a salt flat. When we look at the geological record, we see a pattern of repeated vanishing. Seas have dried before, leaving deserts and mountains in their place. Each disappearance was the result of Earth systems interacting, the solid crust rising or sinking, the air growing warmer or colder, the water evaporating or flowing elsewhere. Nothing about this balance is permanent. The science of vanishing oceans is not only about the past but also about the present. By tracing how tectonics, evaporation, and climate work together in deep time, scientists can better understand the fragility of the seas we depend on today. The same forces still operate, though now they are joined by human activity, adding new pressures to an already delicate system. Water, so abundant and life-giving, is also vulnerable. The seas remind us that even the grandest features of our planet exist only by grace of balance, and when that balance shifts, what feels eternal can quietly disappear. When seas vanish, they do not leave in silence. They leave behind traces, lessons pressed into stone, and warnings whispered in dust and salt. To walk across the floor of a dead sea is to walk across a library written in minerals, fossils, and scars. Each layer of salt and sand records not only the collapse of water, but also how life responded, how ecosystems faltered, and how some endured despite the odds. The first lesson is resilience. Even when seas shrank and waters grew briny, some organisms clung to survival. Tiny crustaceans adapted to higher salinity. Algae bloomed in harsh conditions, staining pools red or green. Fish sometimes evolved into dwarf forms, their bodies reshaped by the limits of shrinking space. These survivors tell us that life bends before it breaks, that in the harshest corners of Earth, biology searches for a way to persist. Yet resilience has limits. Once salinity reaches extremes, or once oxygen runs out in stagnant waters, even the hardiest forms of life perish. The record of vanished seas shows both the creativity of life and the edge beyond which no adaptation can carry it. The second lesson is fragility. Entire ecosystems once flourished in inland seas, home to reptiles, fish, and countless invertebrates. When water levels dropped, the collapse was not gradual for all species. Some perished quickly, unable to adjust to the changes in temperature or chemistry. Fossil beds reveal sudden die-offs, layers of skeletons piled together in what were once shallow lagoons. These deposits remind us how thin the boundary is between thriving abundance and empty silence. Life may appear secure, yet the balance that sustains it is as delicate as the edge of a tide pool drying under the sun. The third lesson is change. Seas have risen and vanished many times across Earth's history. Each disappearance rewrote landscapes, climate, and the possibilities for life. Where seas retreated, deserts often spread, carried by winds that lifted fine dust into the skies. That dust traveled across continents, fertilizing soils half a world away. In this way, even collapse carried within it the seeds of renewal. Ecosystems may vanish in one region, but in time, their remnants and nutrients feed growth somewhere else. Life does not end in a single basin, it flows outward, finding new homes. The story of vanished seas is therefore not only about endings, but also about beginnings hidden in their aftermath. These vanished seas also teach us to pay attention to warning signs. Salt domes rising beneath modern landscapes show where waters once boiled away. Cracked lake beds foreshadow future collapse as rivers fail to replenish shrinking basins. Dust plumes traced by satellites reveal where new deserts are forming, carrying the memory of lost water into the sky. Even in places that still glitter blue, such as the Caspian or Lake Urmia, the slow retreat of waterlines speaks the same language as the vanished seas of the past. The lessons are clear. If we choose to read them, water is not guaranteed, and what looks eternal may already be vanishing. There is also a human lesson in these ancient stories. Civilizations have always leaned on water as a foundation. Vanished seas remind us how quickly that foundation can crumble when the balance tips. Salt, once a gift left behind by vanished waters, shaped trade and empire. Yet the same salt crusts can poison soils, suffocate fields, and drive communities away. The paradox is striking. What nourishes also destroys. What sustains can betray. Ancient peoples knew this, weaving tales of floods and deserts, myths of drowned worlds and cursed wastelands. Their stories echo the geological truths, still written in stone. Perhaps the deepest lesson of all is humility. Seas that stretched for thousands of miles once seemed eternal, yet they disappeared. Whole oceans that linked continents are now gone, leaving behind only mountain ranges and deserts. To remember this is to understand that permanence is an illusion. Earth is restless, always reshaping itself, always rewriting the rules for life. What survives is not what resists change, but what flows with it, adapting and shifting as waters do. Every vanished sea leaves behind a message. Fossil beds teach of ecosystems that once thrived and then collapsed. Salt flats mirror the fragility of balance. Dust storms carry reminders into the air, reaching those far removed from the vanished basin itself. Each reminder whispers that life is both resilient and fragile, and that even the most immense landscapes are subject to change. The sands, salts, and fossils that mark the graves of seas are not only evidence of the past, but also signposts for the present. They remind us that the systems supporting our own world are vulnerable. Just as inland seas vanished when climate shifted or rivers failed, the waters we depend upon today may follow the same path if balance is lost. The story of vanished seas, then, is not only about what once was, it is about what may still come, and what we can learn if we listen to the memory of water written in the quiet pages of Earth's stone. Imagine standing on land where once a sea stretched to the horizon. Beneath your feet, the ground is hard and cracked, etched with the memory of water that no longer exists. Salt crystals shimmer in the sun like the ghosts of waves. The air is still, heavy with silence, as if the wind itself remembers that it once carried the scent of salt spray. You close your eyes, and for a moment you can almost hear it, the rolling crash of waves, the low hum of distant tides, the calls of creatures that swam in a world now gone. Then the sound fades, leaving only stillness. This is what it means to witness the scale of loss when seas vanish. The absence is not small, not local, but vast and planetary. It is a silence that covers hundreds of miles, where once there was life in endless abundance. Imagine the western interior seaway of North America, a sea that once stretched from the Gulf of Mexico to the Arctic, filled with mosasaurs, ammonites, and sharks. Today, all that remains are dry plains and fossil beds. The difference between then and now is not subtle. It is a gulf so wide that it shakes the imagination. A world of living water reduced to a desert of stone. Loss on this scale reshapes not only landscapes but also memory. The ground beneath your feet becomes a paradox, solid, yet haunted by what is no longer there. Scientists read the history in the rocks, layers of mudstone and chalk whispering of plankton blooms, of warm, shallow seas, of creatures that thrived in sunlight filtering through ancient waters. Now those same rocks crumble under the weight of sun and dust. The silence is not empty, but full of echoes, as though the land remembers every wave that has touched it. Think of the Sahara, a desert so vast it seems timeless. Yet beneath its sand lie fossils of fish, crocodiles, and hippos, reminders that this dry expanse was once green and wet. To stand in that desert is to feel the fragility of permanence. Something as immense as a sea, something that seems eternal, can slip away until only memory remains. The desert carries that memory in stone, but to human eyes the contrast is startling. The scale of life that once filled it, now reduced to wind-blown dunes and dry silence. The emotional weight of these vanished seas comes not only from what they were, but from how complete their absence is. Oceans feel eternal to us because we are small against them. Standing on the shore today, watching waves stretch far into the horizon, it feels impossible to imagine that such immensity could ever fade. Yet the fossil record tells us otherwise. Seas that ruled over continents have dried to nothing. Inland oceans that once split land masses have been erased as though they were never there. To recognize this truth is to feel both awe and unease. Awe at the power of Earth to transform itself, and unease at how fragile even the largest things truly are. It is not just landscapes that are lost, but entire worlds of sound and movement. Where waves once lapped, there is now only wind. Where whales once swam, there is only stone. Where coral reefs once shimmered with color, there are only dry salt flats reflecting the sun. To walk across such places is to feel the weight of absence. It is as if the land holds a breath it can no longer release, as if the echoes of life are suspended in silence, waiting for water that will never return. The scale of loss is emotional because it forces us to confront our own assumptions. We think of oceans as eternal, mountains as unchanging, skies as endless. Yet Earth reminds us, through vanished seas, that permanence is an illusion. The oceans themselves, vast and powerful, are part of a cycle of rise and retreat, expansion and disappearance. Nothing is beyond change. Nothing is beyond loss. There is a quiet humility in this realization. It brings us closer to understanding our place in time. We are brief compared to the ages of seas and continents, yet even those immense bodies of water are not eternal. To imagine whales swimming through what is now desert, or ships stranded where waves once ruled, is to feel the fragility of every world we take for granted. The seabeds turned desert are not only geological records, they are emotional mirrors, reflecting back to us the vulnerability of things we assume will last forever. They show us that loss on a planetary scale is possible, that even the largest seas can vanish, leaving behind only silence, salt, and stone. And standing on that silence, it is difficult not to wonder what else we believe is eternal, but may one day be gone. Across the great span of time, Earth has written stories not only in mountains and skies, but in the seas that come and go. Waters have risen to swallow continents, then retreated to reveal deserts. Oceans that once seemed eternal have left behind only silence, salt, and stone. The western interior Seaway once divided North America, and now its memory lingers only in fossil-rich plains. The vast Paratethys once stretched across Europe and Asia, only to vanish into dust storms and salt domes. The Mediterranean itself nearly disappeared in the Messinian Salinity Crisis, before returning in a flood so sudden and vast it reshaped the land. Even the Tethys, once a world-spanning ocean, is gone, replaced by mountains and deserts. Each vanished sea tells us the same quiet truth. The surface of Earth is never still. It is a canvas constantly redrawn by tectonic plates, by climate, by the slow turning of orbits and the restless energy beneath the crust. Seas dry, lakes retreat, and in their absence, deserts bloom. Life adapts or vanishes. Fossils of whales appear in deserts where waters once surged. Layers of salt glitter like monuments to the silence left behind. Dust carries memories across continents, so fine it can settle oceans away from where it was born. To imagine the scale of these transformations is to feel both awe and fragility. Awe at the immense power of Earth, a planet alive with change. Fragility in realizing how temporary even the grandest landscapes truly are. The seas we stand beside today feel unshakable, their horizons endless, their tides steady. Yet the record of vanished oceans reminds us that nothing is fixed forever. The deep blue that feels eternal may one day be a desert, just as today's deserts were once seas. There is also reflection in knowing that life has always been caught within these shifts. Creatures flourished in inland seas, only to be stranded as the waters pulled away. Entire ecosystems thrived, then collapsed, leaving their stories pressed into stone. Some adapted, evolving into new forms in shrinking, salty waters. Others disappeared, their last traces found in fossil beds beneath our feet. Humanity itself has walked the paths shaped by vanished seas, building civilizations on their dry beds, mining salt left behind, and carrying forward myths and legends of floods and deserts. As the story of these seas unfolds, one question rises above all. What else that feels eternal may one day vanish? Mountains wear down grain by grain, forests shift with the climate. Rivers carve new paths, abandoning their old ones. Even the atmosphere itself, which we breathe without thought, has changed dramatically over Earth's long history. The vanished seas remind us that the world is always in motion, and that permanence is an illusion born from our short lives. Yet there is beauty in this impermanence. The deserts that shimmer today with mirages were once filled with waves and tides. The salt flats that stretch like mirrors into the horizon were once lakes that cradled life. The fossils of creatures now long gone show us that life endures, even as seas vanish. In this constant turning, there is resilience as well as fragility, rebirth as well as loss. To pause and listen to these stories is to hear Earth itself whisper. It speaks through salt, through dust, through fossils and stone. It reminds us that change is not always catastrophe, but part of the rhythm of the planet. Seas rise, seas vanish, and in their place new worlds appear. Life is forever changed, but life continues. So as you drift with these thoughts, I leave you with a question. What other things do we believe are eternal? yet may not be? Could the forests we know one day be deserts? Could the rivers we drink from disappear like the Aral Sea? Could the very coastlines we love retreat far inland as seas swell again? These are not questions of despair, but of curiosity. They ask us to see the world as alive, restless, always shifting, never still. If you have found peace in this journey and wonder in these vanished seas, I invite you to stay with this little corner of the universe. Before we part tonight, I would love to know where in the world you are listening from and what time it is there. It is always moving to think of these stories being shared beneath so many different skies, across time zones and continents, like a community, scattered but connected. If you enjoy these calm explorations of Earth's forgotten mysteries, please consider leaving a like and subscribing. A warm thank you to those who already have. You help this quiet space grow, and you keep these stories alive. Now, let us rest for a while with the thought that nothing is as permanent as it seems, yet everything leaves a trace. Even the vanished seas still speak through salt and fossils and silence. The earth is restless, yet endlessly beautiful, and we are fortunate to walk upon it, to listen, and to remember.